Shall we start the session, sir?
Yes, please.
Thank you. A very good afternoon to each one of you. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for this session on two pillars of operational excellence 4.0. The session is organized under the aegis of Industry 4.0 Expert Committee, and we have a galaxy of speakers addressing at the session. Mr. R.G. Periaswami from TVS, Executive Vice President, TVS Motor Company, Mr. Prakash G, who is the CEO of ACE Designers Limited. And the session is moderated by Mr. Rabindra, who is the Chief Engineer at Tata Technologies, and Mr. A.N. Chandramouli, who leads the Industry 4.0 Expert Committee and who is also the Chairman of Industry 4.0. We have with us Dr. Devarajan, who is our Senior Vice President and who is also the Senior Vice President of TVS Motor Company as one of the panelists. The session is divided into two panel discussions, PLM 4.0 for quality, and the second panel discussion is on the theme affordable and intelligent automation. We thank all of you for coming together in addressing on this important subject of the day, sirs. Thank you very much.
Jagannath, you forgot to mention.
Sorry, sir. And the Industry 4.0 Expert Committee is co-chaired by Mr. Jagannath, Chief Operating Officer of M2 Next BFW Subsidiary. Thank you, sir. And really sorry, it was by oversight. I missed it. BCIC acknowledges its annual sponsors, Mrs. Bueller, Fundamax, IAMPL, MTR, Sona Group of Companies, SDMIMD, TVS Motor, Vishwas Group, and Wipro for their support in all the activities of the committee. And now I hand over the platform to Mr. Rabindra. Over to you, sir.
Thank you. Good afternoon. I think the session will begin with Mr. Chandramouli, sir, to welcome the participants and setting the context.
Okay, thank you, Rupa. Thank you, Rabindra Saha. I'll just take exactly 2 minutes to set the context of this panel discussion, which was originally, supposed to be one panel. Then we increased to 2 panels, and we were groping in the dark as to how to set the context of the 2 panels and then connect the two. So we came up with a title called The 2 Pillars of Operational Excellence. And as it were, the first pillar, welcome Mr. Vishwanathan. The first pillar is the digital technology pillar, which is driven by the PLM concept, product lifecycle management. The erstwhile PLM, when it is enabled with Industry 4.0, it takes the shape of PLM 4.0, right? And end-to-end concept of design to after-sale service is captured in the concept of PLM. And we have great speakers today. Rabindra Saha himself is an expert in PLM 4.0. We have Mr. Prakash G, who is going to connect the PLM 4.0 to Quality 4.0, which is a fantastic thing that he has done in terms of connecting it. And we have Mr. Periaswami taking us to the complete cycle of the PLM. We have 2 great leaders from TVS Motor, Dr. Devarajan and Dr. Periaswami. I see anybody in TVS Motor is a doctor, so don't worry about that. So that is the one pillar. My dear ladies and gentlemen, welcome to all of you. That's a one pillar. The digital technology, which enables all these things. Then second pillar, where I come in along with Mr. Jagannath and Dr. Devarajan, is a so-called automation pillar, right? And in the Industry 3.0, automation had its own standalone credibility. But the intelligent automation or the smart automation came in the moment Industry 4.0 was born. And not to speak of the 5.0, I'm sure people are raring to ask about 5.0, which is nothing but the human-machine interface. It's just it's the 4.0, 4.1, I call it, right? So the intelligent automation bucket, the second pillar of the Industry 4.0 or digital technology, is an extremely important pillar. And today, the first attempt we are making as Bangalore Chamber of Industry and Commerce to bring the 2 pillars of the operational excellence. Then you may wonder, sir, so far you're telling whatever we understood. Where is operational excellence coming from, right? Therefore, you must understand the word operational excellence is talking about how to satisfy and delight the customer, as it were, in any of our industries, right? Whether it is a consumer or a customer, industry customer, B2B customer, B2C customer, whatever it is, how to delight him with an excellent quality, excellent delivery, excellent safety, excellent cost position, excellent flexibility, and so on and so forth. If everything is excellent and the customer is delighted, at the same time, the company from which we are supplying is working very efficiently in terms of cost and whatnot, right? Effectiveness and efficiency going together, as Dr. Parasuraman says, our erstwhile president of Bangalore Chamber of Industry and Commerce, right? Then we reach operational excellence. So I don't want to talk too much now. We have excellent presenters today. Suffice to say, the two pillars are standing on a strong foundation of operational excellence. At the same time, the two pillars enable a strong roof called Operational Excellence 4.0. Thank you very much. We will meet once again at 4:30 with my session. Thank you very much. Over to Rabindra Saha.
Thank you so much, Mauli sir. And I welcome to all the participants and our panelists into this event and session. I'll just share my presentation deck. Just a quick check. Are you able to see my screen? Sir, Mauli sir?
Absolutely. Yes. I can see the screen. I can hear you loud and clear.
Yes. Yeah. So as Mauli sir has spoken about that there are two pillars. So first panel discussion is themed with the quality 4.0. So before that, the way Mauli sir spoke about that PLM is the foundation of connecting all the stream and the department. So before begin the panel discussion, I would like to talk about 5 to 7 minutes, giving an overview of the PLM product lifecycle management. So before that, the small correction, the name of spelling correction, Tata Technology, it's a Tata Technologies. So initials before slide start, it was spelling was correct. So that's small correction. So I'll give a keynote on the product lifecycle management, which will collect all the department, and what is one of them is the quality 4.0, and the various aspects to the panel discussion. Two will be connecting together. So after that, we'll get into the discussion, and we will have Mr. Prakash speaking about quality 4.0 for his perspective. We'll do a kind of 20 minutes presentation talking on that end, followed by Mr. R.J. Periaswami, Executive Vice President, NPD TVS Motor. He will share his insight and his experience on quality 4.0. Once both the presentations are over, and then we'll get to the kind of panel discussion. I will have the question based on their presentation, and then followed by questions taken from the audience and all the participants. So having said that, I'll just have just set the context on an overview of product lifecycle management. So I'll start with first talking about bringing two challenges which across the industry we face. The one of the first challenge in engineering domain across the industry is that data management, change management, various functions primarily work on silos. Interconnectivity is a challenge. Cross-functional connections, sharing, change and revision management, and then and this leads to the kind of delays in the product launch, the issues coming from the quality, managing large data, multiple information. So these are the kind of the challenges which across the industry in engineering space we face it. The another challenge number two, which I have put out over here, is that earlier we had kind of a point solution on the software related to the product lifecycle management, and all the domain like design, CAE, manufacturing, and others are working in the silos. All the solutions were not connected and working as a platform. So those are the challenges which we see. I am highlighting as the challenge too. And typically, we need to use the third-party plugins to bring the data from here and later. So seamlessly collaboration doesn't happen, and there are a lot of data losses has happened. So this particular, the slides talks about the various aspects of the challenge number 2. Having said that, the challenge 1 and challenge 2, I have mapped that kind of different technology used across the product life cycle. It's a very nice mapping I've done is, as I spoke about, the PLM 4.0, where the digital technologies are used across the value stream or of the product development life cycle. Start from design, manufacturing, validation, metal flow, and the visualization, and Industry 4.0. So this is summary of the thing that comes together and are available. So having said before the challenge 1 and 2, I would like to just stress upon on the basics, the definition of the product life cycle. Is primarily process of managing the entire life cycle of a product, from its conception through design, manufacture, to service, to disposal. So entire stage, and the data and the document, engineering document, entire it manages, which includes the various department working internally and externally, including supply chain. So in other words, PLM integrates people, data, processes, business systems, provides a product information backbone for any companies and their extended enterprises. So this is at the very high level the definition, but I'll just talk about that. The second challenge which I spoke about is that the solution technology is available in a standpoint. Now the technology is evolved, which provides as a kind of integrated, collaborative, platform-based solution, where the solution provided in design area or the CA area, manufacturing area, quality area, so all are interconnected, and this works all works on a one particular platforms. Only is that just to define the role, get the access, and that the modular version is available to the user who is working on it. So here the data management, seamless integration, collaborations, and faster time to market, that all happens. So a lot of effort earlier used to go to data management, etc., integration, that goes away by using the integrated platform based collaborative experience. So this now all these softwares, a large number of softwares technologies are provided as a platform based collaborative. So the thought is that yes, we should adopt for kind of technology which provides connecting with all the department, platform, and collaboration happens in that way. So that the technology has evolved, offered by the various OEM softwares. I will just a small touch upon that how the PLM growth happens. If you see at the left hand bottom, the decades back, we used to work on the 2D drawing, primarily started with the drafting board, etc. Started working on the 2D. Then the evolution of the 3D, the CAD data comes where used to do the 3D model for designing, but not much of users in the kind of manufacturing happens. I'm talking about the, say, the 30 or 40 years back kind of thing. Then the evolution happens and we come to the kind of PDM, which is a product data management. So this was only specific to the design data, the BOM management, the multi-CADA management, all various structure were there. So specific to, again, the many more attributes are added to the PDM. But in today, we are talking with the stage 4, where the product life cycle. This covers the entire life cycles of management. In the next slide, I'm going to talk about what are the various stages of the life cycle of management. So it basically now creates a digital thread, which starts from the sales and marketing to design to the all stakeholder agency involved into the product design and manufacturing. And this also gives a platform for Industry 4.0 to collaborate and connect it together. So PLM remains the core of heart of the all stakeholder connecting together. So this particular slide speak about the PLM growth. Now, whenever we speak about the PLM, there are always two areas, two domains comes is. One is the graphic data and is the non-graphic data. So this is where we categorize in the product life. So one is the, when you say the graphics data, the primarily with what we see with the visually like CAD data or engineering, the CAE data or the mock-up, So as a visual tools, a knowledge-based engineering, or DVA, we do dimensional variance analysis. So here, the visually we can see the data of the engineering data. So to put this entire thing in the graphic requirement, but the PLM also manages the non-graphic data like the BOM or the documents, all reports, and the marketing data, all, and there are a lot of documents which gets generated in entire life cycle. So entire documents are managed using the PLM. So both combined together makes the framework of the product life cycle management. Moving ahead, this is a small glimpse of the framework. When we say the PLM framework, it covers starting from the design, the NPI, new product introduction, the projects where with the project and facility planning, the sourcing departments comes where the supply chain related things happens, then production, then the quality, sales and marketing, and ERP related. So starting from the design where we measure the design data, CAE, prototyping, all related graphic, non-graphic data is management. And if you see the center, we have got the PLM, and we call that a single source of truth, because everyone always access the data real time available as center. Stakeholders are lively connected here. And a new product introduction is that the simultaneous engineering, when you build the product as a kind of prototype, so all this data come project line, like kind of digital factory, process related, sourcing, supply chain, because a lot of data is we also need to pass it to our suppliers, and then connectivity can be established the PLM, and we can pull it to the data based on the access control. Production is there, where we require a lot of data for their operating procedure, process it, and various tools, facility, how to do it, all comes from the PLM. Quality data, which is the talk of the today. So any aspects of the quality data, or that he required the data or engineering data to be pulled out for the PLM, and he cares some own data, and all is gets faced back to the PLM. Sales and marketing data, they connect with the data, and then ARP require the many aspects, because they are involved in the business, the kind of the map, the kind of purchase and sales and HR all comes, but all they require is a kind of the data, the BOM, to do the kind of the standard man hours, the costing of the product, and many other aspects, material management is all it. So this particular the frameworks talks about that how single source of truth is the PLM at the core, all stakeholder is getting connected. So if you see that the quality is a very, very important discussion, and we are going to talk about Quality 4.0 by our two on the panelist will stress upon that. So it's important that I said the context of how this integrate is that. Having said that, the is primarily the PLM enables the digital thread. When we say the digital thread means it's generated from the versions, and all stakeholders are getting connected. So it's a single source of data truth, creating collaboration across function, stream, supplier, partner in real time. But all stakeholders may not be accessing the native data of the format. He may access the neutral format, which is lightweight format, which goes to the all other stakeholder connected. Because when the source which generates the data, who manages the native data? Otherwise, rest of the thing lighter format is managed. So this so the PLM is scalable, enables enterprise-wide accessibility, digital data continuity, and across traditionally sizeless ways in the work to work efficiently, effectively with the speed of innovation. So these are the, I have summarized that kind of, it brings the benefit of the product life, faster time to market, it creates a digital twin, digital trade, industry 4.0, manage the complexity, manage the supplier collaboration, project management, productivity, and multiple layers can be add onto this based on the business requirement and that. So having said that, giving overview on product lifecycle management, now we will move to the panel discussion, and is a PLM for Quality 4.0. So I will welcome first Mr. Prakash ji. I would like to introduce first Mr. Prakash ji, the chief.
Before that, I want to say that was a brilliant beginning and such a concise treatise of PLM I never heard in my whole life and career, and definitely in the recent past. Thank you, Dr. Rabindra Saha, for this wonderful, crisp explanation of PLM. Thank you, sir.
Thank you so much, sir. So welcome, Mr. Prakash ji. Can you hear me? Quick check.
Yes, I can hear you. Please go ahead.
Sure. So before I handing over to you, I would like to introduce Mr. Prakash ji. He is the Chief Operating Officer, S Designers Limited, and he comes with a very, very strong foundation of 30 years of manufacturing experience in various kind of operations. Currently, he is working as Chief Operating Officer, overseeing the operation of the S Designers Limited turning division, which includes all the SBUs, component manufacturing, supply chain, while being accountable for meeting revenue targets, improvement of cost, quality, and margin. Apart from that, he worked for Toyota Chrysler Automotive for the period 1998 to November 2022 in manufacturing, engineering, quality. He also worked at Toyota headquarters, Aichi, Japan for 2 years in the year of 2003 to 2005 in production and engineering department, and the core areas was primarily in the engine line design and setting up. He also worked for the Ken Metal Vidya for the period of 6 years in the machine tool division. And he comes with the education background. He is the BTech in mechanical from RB College of Engineering, our own Bangalore, the college. And he has done the manufacturing management MS in BITS Pilani. He has also done MTech from BITS Pilani in digital manufacturing. Apart from that, Mr. Prakash is involved in as a member of Manufacturing Expert Committee, BCIC, Bangalore Chamber of Industry and Commerce, Vice President of Bangalore Chapter Indian Society for Quality, life member of QCFI, and we know that QCFI is primarily for the Quality Circle Forum of India, certified trainer for Toyota business practices and integrated problem solver, keen follower of Toyota production system and theory of constant management. So this is a wonderful background and the vast experience. I welcome Mr. Prakash to share your insight on the Quality 4.0. So over to you, Mr. Prakash. Stage is yours.
Yeah. Thank you, Mr. Rabindra Shah. And I would also like to thank Mr. Chandramouli for actually giving me this opportunity and the platform to share my experience. And the subject also is a very interesting subject. And I would like to also thank the office bearers of BCIC for creating such a session for the interest of the participants as well as the members of the BCIC. Due to bandwidth, I'd like to switch off my camera and then I would like to share my my thoughts through these few slides. Probably these slides are not enough, I felt, but however, I'll make my best efforts to explain my thoughts through these slides. And I think my thoughts, initial slides are actually quite concisely already presented by Rabindra Saha. So maybe I will rush through that, but I think maybe it will help once again to all the audience and the participants to understand better the concept of PLM.
Thank you so much, Mr. Prakash. Please, over to you. Please, you can present your screen.
Yeah, thank you. Thank you. I'll just be presenting now. Please let me know whether you can see my screen.
I can see you. I can see you in the presentation mode, and you are very much audible. Please go ahead.
I think that this is the place to start with. I think as the name indicates, we are talking about a PLM and then Quality 4.0. For me, it is actually, I was trying to look at these two things initially as a separate, but when I looked at the fundamentals of these concepts, PLM is equal to IoT plus Quality 4.0, Lean 4.0, I mean, Logistic 4.0. So if you say that all these things put together is actually a PLM. And this is where I felt when I looked at the holistic view of the Quality 4.0, it's actually a part and parcel of the, first, of course, it is part of the Industry 4.0. And then now the Industry 4.0 itself is a part of the PLM. So that way it is more very much interconnected, I felt. Now, the contents of my presentations are quite simple, not so complicated. I would like to keep the presentations to the broader concepts and understanding on what is that rather than how it is. Because how of the quality 4.0, there are a lot of tools, and people, whenever you talk about many tools, you'll find the tools related to industry 4.0, which are quite overlapping with with the quality 4.0 also. So I would like to keep this presentation briefly to the overview of PLM, IoT, and quality 4.0. Here I tried to bring in some kind of a image about what is the linkage between PL and IoT. And of course, the industry 4.0 and quality 4.0. I think we will run through this a little bit just to make people understand where are the differences and where the focus is. And then, of course, quality 1.0 to 4.0, some explanation. And a few slides on establishing and implementing quality 4.0 principles and ecosystem for quality 4.0. And then, of course, we'll come to a brief explanation on the facts and figures related to this quality 4.0 in industry, and what are the ways to win. That means how do we go on implementing it? And there's also a brief on that, and case studies. Of course, these case studies we have taken from the ACE designers. Probably they are very amateur, and I'm very sure there are other industries who are doing much more than these examples. And of course, these case studies will be further appended and strengthened by Periaswami also. I think he has got that kind of an experience and the case studies to deal with. I think the overview portion of it already, Mr. Saha has already touched upon it. I think I just wanted to give an overview from a point that what is this actually kind of the difficulty it overcomes, the PLM. So I looked at this as a primary goal of a PLM is to coordinate the information, processes, and people associated with the life cycle of the product. Generally speaking, you have seen these segmented information sharing, and then you don't see the connect. That's why I think Mr. Saha wonderfully mentioned it as a thread between all these connected entities. So I think from that angle, I think this technology probably eliminates the silos between the functions and the departments to deliver value to the customer. I think that's the fundamental and the purpose of the entire whatever technology we talk about. And of course, the other benefits already was touched upon. Was a reduction in the product's time to market, ease of scaling of organizations. Once you have this kind of a data and thread, productivity and quality obviously will improve. And of course, on the right side, there's some kind of an evolution, because suddenly where this PLM came from, I think people should be having some basic awareness on this. It did not suddenly come from the moon. That actually it started with various things called as engineering data management, and product data management, as was indicated earlier, the collaborative product commerce, then the product life cycle. Of course, after that, we are seeing that how it is getting integrated into Industry 4.0 as well. I think the right side, it just gives an indication about what all the elements of it and what are the foundations for that PLM. An overview of this, probably, I think the capabilities, PLM capabilities for quality has got about 4 main areas. One is on the change and configuration management. Second is on the quality management itself. Third is on the project collaboration, governance, and the workflow. And the fourth one is on the product data management. I think product data management, we have talked about it. I just would like to little bit stress upon one factor, which is called change and configuration management. I think this is a very key aspect, because if you see any product, whenever there is it starts with the development and then it goes into the use, you will find a lot of changes happening in its specifications based on the initial understanding and then based on the feedback. So if this change management is not effectively handled, then you are going to get into a lot of issues related to the recalls or the customer issues and customer happiness. So I think this change and configuration management, which is a very important aspect of the PLM, it makes the dynamic and fast-paced coordinated changes throughout the product lifecycle to ensure all stakeholders are accessing the most up-to-date product information. I think this is the key, because we have seen in every product, I think the product can be anything. need not be only a manufactured product or auto component, or it can be anything, even from a consumer product also, that you will not, if it's not up to date, you will end up with servicing the customer with the older version of the product itself. So thereby the customer, there will be a kind of a differentiation. Customer feels that something you are giving us a very bad quality of product. So I think this up-to-date information and the change management is a very key aspect, which I feel is a strong point of the PLM. And other aspects, I would say that quality management, I think this is the foundation for the any kind of technology. Basically, it is to look at continually improve the quality of the product and reduce the service instances to improve the customer satisfaction. The other aspects, I think, well written and well said by others. The second right side, I would like to just draw your attention on the people aspect. Basically, it's imbibing the quality in every aspect. That means to say, we talk about this from a point of view of the first time right. Now, when we say first time right, it's also important that when you say first time right, it's also about decision making. That means what you actually, when you make a decision, whether it is right, perfectly right, or nearly right, it needs this kind of, to avoid rework. Second one is, of course, it also gives a very structured approach through standardization and decentralization of the work. So this is very important, actually. Standardization and decentralization, it's difficult to comprehend for a common man. But I think this PLM actually helps in doing that. And of course, the roles and responsibility, the analysis of life cycle through workflow. So these are some of the aspects I felt PLM and quality can have, there's a good linkage. Having said this, I would like to draw attention because we are in the world of a lot of technologies. The lot of words are coming up in terms of various aspects, and sometimes the end user is almost getting confused about various technologies and the use of it. So I just draw an attention to all the audience on any technology. I think it has to answer the 6 fundamental questions, if you want to really get the benefit out of this technology. So here, I think these fundamental 6 questions I would like to repeat because it's going to help anybody who is going to get into any of this technology usage. So what is the power of this new technology? We should be able to clearly articulate and understand. This is very important starting point for actually imbibing any new technology. And second one is what is the current limitation or a barrier does the new technology eliminate or vastly reduce? Why I brought this very important point is if you look at the IoT, an example, need for human or a physical intervention for interaction between entities for a problem resolution. For example, if you would like to see the machine problem to be resolved, there needs to be a one person standing in front of the machine, completely watching, seeing what is happening. Now, this has got replaced with completely sensors built into all kind of elements of the machine, and each one throws of the data. And what's required is only a remote data collection and analysis. And then only when there is a need for a physical change of a part, the human intervention is required. The rest of the things is still done digitally. And how does this PLM actually look at this limitation? Basically, if you see before the PLM, used to have a lot of walls, silos, and rules which used to exist. Without the digital thread, the people used to manage it. How it used to be managed is basically kind of central repositories at a fixed time of interval. People used to go and log in and check, and all these kind of rules were already there. And these rules are actually completely broken with the availability of this technology. That means you can at any time, because of the lack of real-time information between the function, the entire product life cycle, now you can easily manage it. Similarly, at the same time, in the absence of the technology, you would have built in some rules, patterns, and behaviors that bypass the limitation. So usually, when you don't have the technology, you would have managed in a way which is, you would have built your own rules to manage that condition. Of course, it may take more time. At the same time, what rules and patterns we have to change when you bring in a new technology. So this is very important, basically. Usually, you will find any new technology when you introduce, if you don't change the behaviors, if you don't change the rules, or if you don't look at the people from from a HRD point of view, it's almost you will not be able to get the benefit of this technology. Similarly, what is the application of the new technology that will enable the above change without causing resistance? I think this is very key aspect. Probably nobody talks about this. We say that for anything, any technology, behind that there is a people. Otherwise, any system, or you call it as a management system or a technology system, technology management, behind that it is people. So bottom line is that the people's development, people's reskilling, upskilling is the key for actually embracing the new technology. And last one is how to build, capitalize, and sustain the business. This is the last point which any new technology has to actually address. So here I've just given some comparison. Probably it can be debated, but just for example of IoT, we need to develop standards and modular functions to scale up. Probably now the IoT lacks this area. So I thought that I think this requires kind of attention from all. And I'm very sure even the government of India is also trying to look at how to scale up this Industry 4.0 adoption to MSMEs also, and they're looking for a lot of inputs. Probably this is one of the input which probably 2 years back, under the leadership of Chandramouli, I think we did make a representation to the government on this aspect. On the similar way on PLM, I think we have to develop a sector-specific PLM standards and modular architecture to bring down high cost and time of customization. I think this is one of the important aspect. When you look at the PLM as an architecture, probably it is available. But if you go into whether it is an SAP, whether it is a PLM, you need to do a lot of high level of customization. So, which means to say that if you are trying to modularize to the industry, some sector specific industries, probably you can bring down the cost of implementation, because the cost of PLM could be very small. It could be very low, but the implementation cost is very high. Similarly with SAP. So I think this requires the kind of a discussion and debate on this aspect to make it more affordable, the PLM. As of course, this is just an example comparing IoT and PLM. There's an example from recently, number 2 automaker quality issue. Basically, the recall covered around 2023 model, 2 models with a 3-cylinder 1.5 liter engine. The defect was basically oil separator housing could crack and develop a leak that would cause an engine fire. Of course, this is proactively done by the automaker himself. Here, if you see the slide, how can you demark between IoT and PLM? IoT actually helps you in getting into the traceability portion. That means identification, report of the car details like condition, location, status of troubleshooting, and also the part details when it is produced. The outcome of the IoT product focuses on fixing the problems, trying to go to the root cause and then look at the fixing the problem where it occurred. While the PLM actually acts as a very nice central repository of information, comprehensive details on number of cars, recalled cost of details, average stack time. This also helps us to focus on not just on solving just the problem, but also helps in betterment of the process using the qualitative data obtained and behavior and trend observed. So this is one example how I thought we can compare IoT and PLM, as PLM is a big brother of IoT, I can say. I just give you, I think already some portion is already touched by Mr. Rabindra Saab. Its Quality 4.0 is not just a technology, it's more than the technology. Of course, it drives the improvements across the value chain. You will find that in the manufacturing, probably it can help you in the predictive quality using machine vision, quality control, digital SOPs on the touch screen for manual assembly. On R&D, probably it will help you on agile product development, usage pattern data, advanced analytics to support decisions. Service and after sales, probably you will have a warranty management enhanced with IoT and analytics, remote quality diagnosis with for the customer support. The procurement portion, I think here it's related to the supplier performance dashboards, integration of supplier quality and data analytics. And then when it comes to logistics and sales, probably it will be addressing centralization of the quality data, end-to-end quality management system, and quality cost transparency. I think this is aspects which I think people have to understand that Quality 4.0 is not just a tool of an IT tool, but I think it's more than that. And this is an overview of the what we say is it's more than the technology. Now I'll just get into a little bit more on, I think everybody is aware of the Industry 4.0. I don't have to repeat it, but I think similar an effort is being done and to look at even quality 4.0. What is quality 1.0, 2.0, 3.0? So the reason is it's very important to understand that how it has progressed so that we don't reinvent or we don't go back to the history again and again. So from that angle, I would say quality 4.0 is a subset of Industry 4.0. And I'll get into little details about each one. What is quality 1.0? I think when we say Industry 1.0, which I think if you compare it to quality 1.0, it predominantly focused on basically on basic quality is assured through inspection. So that means it's not actually looking at quality built into the process. It's more of inspect and decide, inspect and say go or no go. And basically inspection did not focus on looking at the cost reduction or elimination of waste or loss and inefficiency. So that was a very, very primitive stage. It was in prior to 1890. Then we move on to the quality 2.0. Basically here was more focus on adherence to the standards or the specification. Basically, that reflects minimally acceptable quality levels, which is that point of our time. That means when you look at the lower tolerance limit and the upper tolerance limit, as long as within the tolerance limits, we say that's okay. I mean, there's nothing wrong about it. But I think second aspect is also that when you look at the quality 2.0, the mindset was on financial quality is basically measured on scrap and rework, more on the scrap itself. So that was a kind of a quality 2.0. Of course, comparatives on Industry 4.0 is on the left side. I don't want to get into the details. Similarly, on quality 3.0, probably here is a transition which has taken place towards what I would say are a more mature quality. It's became almost a business imperative. It was more focused on meeting customer requirements. It continual improvement initiation started with in this time and led by various very big industries. Of course, very both in terms of the Six Sigma and also the TQM principles almost started gaining during this period of time. And standardization activities started. ISO 9001 became quite imperative, and also the Ball-Bridge criteria for performance excellence. All these kind of things emerged as part of the quality point 3.0. Now, we'll talk about quality 4.0. Basically, it's no more related to meeting the specification, meeting the customer requirements. Basically, it's more of built-in quality. Basically, we start looking at quality shifts from its control-oriented focus to the more of process operators to the process designers. So a shift is happening in this area. And one important thing, if you see the quality 4.0 is machines learn how to self-regulate and manage their own productivity and quality. And a good example today, I will slightly touch upon an effort which is done by aegis designer in this area. And one example I can quote here is an adaptive control in a machine where it automatically adapts based on the actual measured value. That means there's no need of a human intervention, and you're almost getting the quality of Six Sigma quality. So that's where quality 4.0 right now is being placed. Now, let me just touch upon establishing and implementing the quality 4.0 principles. Mainly, it revolves around, as I said, people, process, and technology. Basically, for people, it's a new way of quality professionals to manage quality with the digital tools now available and understanding how to apply them and achieve the excellence through quality. So when it comes to people, I think it's required that people have to be curious, creative, intuitive, and analytical. Process, basically, as we are seeing more of automated work, definitely the need for flawless process remains the same, if not more important. Existing process will be broken, and the need to educate the next generation of workers to implement new process and strategies will be vital. So when I say process, basically it becomes more very, very important to monitor, prioritize, isolate, and hypothesize and test. Technology, of course, I think need for having a good data. That means, of course, in IoT, we get a lot of data, but I think the data has to be accurate, structured, timely, and quantitative and qualitative data has to be clearly segregated. I think these are the principles of Quality 4.0. Now, we should talk about also the ecosystem of Quality 4.0. Of course, when we say 4.0 itself, the mind travels back to digitalization, and digital transformation. But I would like to just, while this on the left side, what you see is most well known to most of the people when it comes to digital technologies. But I just want to draw your attention on the right side. The value propositions for Quality 4.0 actually fall into 6 categories. It's actually to augment the human intelligence. So not to replace human intelligence. Increase the speed and quality of decision making. Third one is to improve transparency, traceability, and auditability. Fourth one is anticipate changes, reveal biases, adapt to new circumstances and knowledge. Fifth one is evolve relationship, organizational boundaries, and concept of trust to reveal opportunities. Sixth one is learn how to learn itself. No, I think this is one area where I would like to quote here that a very famous video in which there was a video by I don't remember the name of the person. I think he did a wonderful explanation about what is your job. I know when somebody asks you what's your job, generally we describe what is your job as what you do. But I think making people understand that not that what is your job is not what you do, but what goal you pursue is the key. So I think that's where the important. When you come to, for example, if you're a teacher, if you ask what's your job, you say I'm a teacher. It's not so. I help people learn. That's his. When you connect this to the learning methodology, I think the world, there are plenty of opportunities. You can see what a teacher can do. Now, I would like to just draw your attention to the facts and figures. Unfortunately, even though we see the technology is very powerful, but you find that the implementation of the Quality 4.0 is still at a very slow speed. Only 16% of the organizations surveyed have implemented. This data is taken from Boston Consulting Group and ASQ 2018 Quality 4.0 study. So here they have implemented only about 16% and 63% have not started even planning. Even though we know that the expected improvements in key metrics, call it as a cost of quality check, first pass deal, defect rate, rework rate, on-time delivery, customer satisfaction, warranty claims, everything, you still find that the implementation is at a very poor rate. The reason for that basically probably is the front runners are facing a lot of challenges in implementing this Quality 4.0. What are the kind of barriers you find in Quality 4.0? Basically, you will find one of the highest percentage of barrier is on the shortage of digital skills and talent. Of course, followed by unclear digital strategy, lack of quality culture. Now, here when I say lack of quality culture, basically, I don't have to talk about Quality 4.0. It's a basic fundamental. So I think what I felt is the foundations of the quality have to be first built in before any organization looks at Quality 4.0. So where to start? I think most of the time when we start any initiatives, digital initiatives, it's actually the leadership has to be very much convinced and be part of that this is going to give a benefit to the organization. So every leadership in the organization has to recognize the merits of implementation to facilitate for overcoming the barriers. Leadership commitment is required in terms of time, resources, money, and assessment of the organization current level to prioritize for actionable points. The reason is, if you just start with an Quality 4.0 initiative without actually setting the base fundamentals clear, you will end up with multiplying all the mudas or the waste which is there in the system. What are the ways to win? Basically, I feel while the picture is quite clear and this methodology is also on the right side is clearly indicated by prioritizing and identifying and developing. I still feel that imbibing the foundations or the fundamentals of either it is Lean, TQM, TPM, or Six Sigma are crucial to build, sustain, and standardize any Quality 4.0 initiative organization takes. I'll just touch upon, sorry, I think I'm just probably running out of time, short of time. So I've just touched upon some initiatives which ACE designers have taken. The case study I would like to present. I think definitely Mr. Periaswami will also be able to, further expand these examples based on his experience. So one is on the digitalization of quality measurement. So here, basically, we are making a small step towards Quality 4.0 using the MORPAS, board eye inspection of a spindle cartridge. So definitely, we have started this activity, and we have, in a small pilot area, we have started and able to capture the data, and this data is captured and transferred to the Excel, and of course, the process, the data is analyzed. Right now, it is being analyzed manually. Of course, then the next step is to connect it to the data analytics portion, which currently is in work in progress. But of course, in this process also, we have challenges. It's not that we have everything is perfect. So advantages, of course, you find that it's user-friendly, ease of inspection, automatic transfer of data, all these kind of things. Data is going to be very easily done. But of course, we also have some kind of disadvantages. No? The instrument itself, what we have, is very sensitive. So it means that human intervention is very much required. Skill up is also required to manage this new way of measuring. And each value set record is independent file. Transfer of data to MS Excel has become a little more cumbersome. And the other disadvantages are integrated data analysis module not available. That's what I said. Probably it has to get linked to the data analytics. And the challenges, of course, we have challenges which we have mentioned in the previous. I think it applies to the our organization as well. Second example, I would say it's one of the very important aspect of quality, not just from the part quality, I think process quality, and thereby looking at it. This is basically a thermal error compensation at ACE designers. This is one of the first in Indian machine tools, while other foreign machine tool makers have some models which these things are available. Just to benefit of the viewers, thermal error is an unwanted movement between the tool and the workpiece because of the following reasons: ambient temperature, heat, internal heat generation, heat generated during machining, and coolant. So basically, this thermal compensation is a prediction of error based on temperature measured by the temperature sensors kept at strategic locations on the machine. So this is the first of its kind. It's not about a measure and correct, but it's more on a trend which is done for about a 1-year exercise. ACE designer took this exercise along with IIT Madras, and they come out with, along with the FANUC, they've come out with a complete module, whether you call it as an artificial intelligence or a mathematical module, where the compensation error without the compensation, the quality would have got drifted by about 25 microns. Now we are able to bring down, thereby the process capability is achieved. What I would say in a nutshell is it's a shift from measure and correct to the predict and prevent, which means you are able to get a very, very stable quality. That's where I would like to end my presentation, and I think the question and answers we can always discuss. So I would like to now hand it over back to Rabindra sir. Thank you very much.
Much of insightful sharing your knowledge and case study, and we learned that how people process technology enables the kind of operational excellence. Thank you so much. And we also learned a very important digitalization of to achieve the quality was the basis step, and every sector specific we need to have a standard. Cost of PLM may be less, but implementation should be high, and because we need to set the process and practices and etc. And IE2 is the key aspect of traceability and fixing root laws. And I also learned today that safe connected machines, adaptive cruising, adaptive control of machine is very, very important in quality, and it is being implemented. Thank you so much. It's very nice connecting the PLM and quality. Thank you so much. So I request you just to maybe we will ask Mr. Periaswami to speak about it. Then we get back connected together to have a kind of discussion. So thank you so much.
Thank you.
And I'll just take Mr. Yeah, 1 second. So we have now second panelist, Mr. R.G. Periaswami. Are you there? Are you able to hear me, Mr. Periaswami?
Hey.
Okay.
Are you able to see me?
I have to close my. I assume yes. Yes. So can you see my screen?
Yes,
Just a quick check.
Yes, yeah.
Oh, thank you.
Yeah.
Thank you, Mr. R.G. Periaswami, for your time and connecting for the panel discussion. And to just speak about Mr. Periaswami, is Executive Vice President in New Product Development, TVS Motor Company. And he brings a very strong industry experience and a leadership role with 34 years of industry experience. And he has been associated with TVS Motor Company since October 1987. He leads the company's new product development initiative. In his current role at TVS Motor, he oversees the implementation of new product development strategy to drive innovation, new products to customers across the globe. Prior to this, Periaswami was head of quality from 2008 to 2018. It was during this reign he led transformation journey at TVS Motor Company for excellence on quality, and consequently TVS attained the #1 position for best in class quality and highest appeal in JD Power ranking for 4 consecutive years. In these initial years as head of NPD, his innovative strategy helped to complete transition of all their two-wheelers from BS4 to BS6 in just 10 months of time. Compliments to you. As an integral part of various departments within the TVS Motor, Periaswami brings with him over 34 years of industry experience in quality assurance, purchase, information technology, new product development in varied business environment in India. His areas of specialization and interest include NPD strategy, change management is very, very important. We saw in the previous session, quality excellence, customer understanding, leadership development, and Six Sigma black belt problem solving. After completing his mechanical engineering in 1986, Periaswami pursued his MBA in marketing and MS in engineering business management in 2004. So much of vast experience, and I welcome Mr. R.J. Periaswami. And now session is yours, and you can start, please. I'm stopping my presentation. You can just present your screen.
Good afternoon, everyone. Thank you, Mr. Rabindra. Thank you, Mr. Prakash, for the detailed presentation. I'll just share my screen.
Please. So I'll just take a few seconds. I request all participants to post their questions in the chat window. So after Mr. Periaswami's presentation is over, we'll get into the kind of discussion with both of them, and I will take up your questions also with the panelists. So please do share, post your questions in the chat window. Thank you so much. Over to you, Mr. Periaswami.
Yeah. Is my slide visible?
Yes, visible, Mr. Periaswami. Please go ahead.
Yeah, slide is visible, sir.
Oh, sorry.
Thank you.
Yes, you are visible. I was mute.
Thank you. So, thanks, Mr. Rabindra and Prakash. You have taken through the entire PLM and how Quality 4.0 is connecting and converging all the data into quality excellence. So I'll just touch upon very little on the Quality 4.0 concepts, but more on we in TVS Motor, how we have tried to work upon some of the areas to bring significant difference in perspective, especially on customer focus using this concept. So as I said, we look at everything with the end customer as the primary focus, and all our processes, supplier quality or design quality or testing quality or manufacturing quality, everything is connected in alignment to the end customer requirement. So I would say in each of the area we have done a digitization, and I won't say we are at 100% now. We are around 40 to 50% connected, and from these how we are trying to use the data to bring out new perspective. That is what will be the case studies what I will be showing through. So at the design stage, what we are looking for is how the product design and process design will connect to the shop floor data. So primarily we look at how FMEA, the checkpoints, or the engineering standard, or the drawing, the R parameters and CTQ parameters, how all this seamlessly connect to the control plan, process FMEA, and the work instruction. We also look at how the shop floor execution data gets connected to the process data. So all the three are digitally fully connected, and we have a seamless interface, because most of the time one of the failure mode what most of the industries go through is there is a customer requirement, there is a engineering drawing, there is a shop floor standard. Each of this do not seamlessly connect. That leads to delay in updation of either of this, leading to a problem at customer end. It is not going.
It's moving now, but it's
So the prerequisite in our journey, what we found in building this is primarily looking at key performance indicator in each of the area. Either in first at the customer end, how do we capture warranty data, or the things gone wrong data, how it is getting stratified into region wise or kilometer wise or age wise. Then these are one set of data remaining at the customer end. Then manufacturing, when you come, how is the appearance quality, how is the rework quality, line wise, shift wise, or operator wise, through using various tracing mechanisms, traceability system. Then at supplier end, similarly, rejection at supplier end, line rejections, or the problems at supplier end, part wise, model wise, line wise. Similarly, at product design, drawings and test standard, these are two areas we found a lot of connectivity, having a gap between drawing and the test standards. Then moving to FMEA and another interesting learning what we had is the engineering standard need not be common across all the products, because each of the products are used by different types of customers. So it has to keep varying between the segments. Then coming to the process design, the process FMEA and control plan, how it is connected as well as to the inspection standard. These are so what we learned was the prerequisite. The most important prerequisite is do we have the comprehensive list of KPIs across the key processes. That is the most important factor to look upon.
we are not able to see your screen.
Yeah, that's why.
It's coming. Yes. Can you see it is happening?
Are you able
I
to see
think
my
I'm blank. Now it has come.
Now it is come.
What is
It's
TGR?
coming. It's coming. Yeah.
Okay.
TGR 7 out of 30. Yeah.
So my previous slide is not visible, unfortunately. Okay. It is about how we build the power of test towards the customer. That is my first case study. And before going into that, I'll touch upon what is TGR and some portion of this slides are not.
I'm able to see use cases, simulation, power of test, defects, and big data analysis.
Oh, okay. It's not visible to me.
Okay, okay. Just hold on. Can you see now?
Okay. Yeah.
But
Now
Go
it's
first. It's possible
so,
to see. Possible to
yeah.
see. Yeah.
I'll show the first case study will be on the simulation power of test. Before that, I just want to touch upon what is TGR. We categorize quality into two parameters: TGR, things gone right, and things gone wrong. So, most of you would have picked up this Karno's model of quality, where we look at what are the areas if you give more of, that will really delight the customer. So we always look for what are the areas we can give more, and which are those parameters if we give more, customers will be delighted. Those areas we call it as TGR. And this is TGW. There are another set of things which are must have. If this is not there, customer will feel really let down. So those are called must have, that if you make any mistake here, customer feel highly dissatisfied. So this we call it as things gone wrong. So I'll just touch upon first how we are trying to build TGW as well as TGR using customer usage data. So each of what we have learned in each of the geography of our country or across the globe, the customer usage varies in different parameters in a different way. For example, the way he operates the engine, the range at which the engine he operates, the RPM range, or the number of times he applies the clutch, or the number of times he applies the brake, or the number of times he goes to the fuel station. Each of this are part of customer usage data now. Those days, these data are very, very difficult to track. Whereas today, most of the vehicles are connected, and these connected platform gives all the information that is required to capture the customer usage cycle. So based on the usage cycle, we get different geographies, different customers, that is male, female, the age group. Accordingly, we get the customer usage data, and based on that, we relook at the lab life. For example, what we look at is if there is a field failure, we look at what is the current mean time to failure based on the current data. Then we look at how do we simulate this failure in the lab based on the customer usage data what we have captured from the field. From there, we look at what is to be improved, what is the design factor or the process factor to be looked upon, and based on that, the MTTF gets improved. Then we estimate the field life in the new cycle. So if you look at originally most of the engineering standards were it will have a fixed number of cycle based on some old Japanese test standard or IS standard, etc. Now every durability cycle has been completely redefined based on the customer needs. That too, it is not on a given day. Every 2 years, things keep changing. So our durability cycles continuously go through the adaptation in line with the customer usage data. So this is one of the example of how we use customer usage data, simulate using 4-quadrant method, leading to durability improvements. Moving to the other side, similarly, the usage data also indicates what are the customers' latent needs, which are not told explicitly by the customer. So we pick up from the usage data, we use machine learning applications and build out what all can be the delight factors. So we use the Kano methodology and capture the delight factors based on certain things he uses more often, certain things he uses very, very limitedly. So based on that, it is decided what to give in the as part of the continuous upgradation in the future products. So this is an example of how customer usage data can be also used through Kano methodology for enhancing the product platform. Then the next use case is about defects, how early we detect and how early we can resolve. Because most of the study shows the best ideal thing is first time. But equally, if you can detect much earlier and resolve, customers can be still recovered. That is the basis on which we looked at this challenge. So this is one of the area where we used IT systems to capture the customer complaints well ahead of time. This is an example of data tracking of a warranty trend. These two types of trend charts what we see in customer complaints. One is normally a particular defect, it was not at all there for some time, slowly crops up and suddenly becomes bigger. And many a time, it will come to many key people's attention only after 6 or 7 months of ballooningly or alarmingly high levels. So the challenge is how do we capture at the very beginning of a small creep? Or there is another data on the right side, what you see is there is a problem, we take action, and after the action, did it come down or not, is also normally immediately not visible, especially where it is a field related issues. In shop floor, many times we can find out the effectiveness of action immediately, whereas here in field, these challenges remain. So we take action 1, action 2, action 3, but with limited successes. This can be this is one typical case. So for both the issues, what we looked at is the concept of statistical process control, that is +1 sigma or +3 sigma. How do we use such a control limit idea into the management of quality systems? So this was the original ASIS process where customer complaint will be there. It will go to dealer service. Dealer replaces the part. He claims through warranty. So he will enter the data into the system. Then that is a separate standalone system. Then the part gets received at our end. Then it is acknowledged by service. Then finance processes it. So the entire journey takes almost 2 months. So in comparison with that, what we introduced was a statistical control limit on a defect customer warranty chart. And this limit has been introduced in the system itself. So it is a digital limit. So we introduced a limit based on that. The moment a dealer punches the data, if there is a sudden spurt in any of the defects, you will get an automatic alert. And if it goes, for example, if it is within 1 sigma level, it goes to the regular person who is responsible for the defect. And if it is more than 2 sigma, it goes to the manager immediately. So the digital data system was exceptionally used to pick up exception at the right time to solve the problem faster. So the whole exercise aided us from moving from monthly PDCA to daily PDCA, and the lead time for data capturing came down from 60 days to 1 day through this digital alert system. Then I'll touch upon the third one. This is on big data analysis using the shop floor data. This is another interesting thing. See, this is the robustness curve, where the left side, that is the bottom, is the input, and the y-axis is the output. And most of the time, we end up operating in the X1. So what if you operate in the X and Y1 area, if there is small variation in the input in the shop floor, it immediately starts affecting the customer. Whereas if you look at the right side, this is the flat portion of the robustness curve, where even if the input is varying this much, your output can be significantly smaller in variation. So you may have a weaker process capability or a lesser process capability at the input parameter, but the output parameter process capability will be significantly superior. So we always strive to look at how do we reach this flat portion of the robustness curve. So I'll just show one example of this. So this is a fault tree analysis for an engine seizure, and we pull out what are the parameters which can lead to the seizure, which part and which parameter. And these are the data coming from shop floor. So every chart is has got almost 7 parameters are there over a period. So millions of data points available already with us. This is the typical situation in any industry. A lot of input data or shop floor data is available. What we did was, we did a matrix plot of each of the data as picked up from the FTA. There are 10 parameters. So these 10 parameters, how is it getting correlated with the same month? What is the warranty failure of this part? So correlation of these parameters, and we identified 7 parameters contribute maximum to this. Based on the subsets regression, we did a further regression analysis, and we identified that 3 parameters: the bore taper, bore perpendicularity, and bore the mating part bore perpendicularity. These 3 are significant parameter leading to the failure. It is not just it ends there. We have made a contour plot of the failure versus each of these parameter. The goodness of this is, we can play around and look at one of the objectives of Q 4.04 is better quality at lesser cost. So now this contour plot shows these 3 parameters, though it is significantly contributing to the failure, even within that, which parameter at what level you can play, so that you can optimize the cost and still win the customer satisfaction. So based on this, what we arrived at is, you can have a crankcase perpendicularity at some level, cylinder block at a particular level, and there is a specification defined for each of this. Still, you can optimize around a different band and achieve best of customer satisfaction at much lesser cost. So in summary, what I would like to say is, utilizing the customer usage data to build customer delight, exception management for proactive quality using digital data control limits, then optimizing the CTQs using DOE or multivariate analysis, so that you can achieve best of customer satisfaction and at much lesser cost. Thank you.
Thank you so much, Mr. Periaswami. Very nice insight and very nice detailed case study. And most important thing is that how we prerequisites the KPI we define it and tracking down to the application benefit. With limited some time, we move. Can I show my screen? Not required. Can we commit to the visual mode? Can you exit, come out from your presentation mode, Mr. Periaswami, so that we start discussion?
Yes, please.
Mr. Prakash, you are there?
Yeah, I'm here only.
So, why? Still, I'm able to see your screen, Mr. Periaswami.
Oh.
You can unshare, I think.
What I'll do, I'll show you, then probably then you can.
If you share, I think it will go out. Yeah.
Okay.
Yeah.
Got it. It's possible to come into. Can we see the visuals also, so that we nicely connect and speak? We are receiving. I request. Yes, Mr. Mouli sir saying is that a superb, nice presentation, true digital quality. Thank you, sir. So we have got some questions also. So before that, I have got some questions to be put to both of you. I start with Mr. Prakash. It's very well articulated, but one thing coming in his mind is that is quality management being threatened by digitization and automation? Mr. Prakash, what would you like to say on this?
Yeah, I think it's a very interesting question. I think there are two aspects of this the question itself. One is the quality management per se, and the digitalization and automation. Now, as long as you look at the digitalization as a completely separate segment, or an automation as a separate segment, then we don't get any meaningful out of it. The reason why this question is being asked, I can say, is probably the quality professionals. If they are hooked on to the only management principles and working on the basics, there is a feeling that there is a threat to their identity in terms of, because the digitalization itself is almost, flooding everywhere. So it's very important that the quality professionals actually learn, or learn the new skills required, how this quality 4.0 can actually complement and supplement the management, quality management itself. So then I think it's not a threat. But if the new learning, reskilling doesn't happen, it's going to be a kind of a threat to the quality management process. But per se, quality management is not getting threatened by the digitalization, but in fact, it is getting complemented and supported very well by the digitalization.
Oh, thank you so much. So reskill, upskilling is very, very important part to really get into this. I see that a lot of questions coming in chat, so I'll take that one. But before that, I have a question for Mr. Periaswami, just coming in mind. Would you like to share your thoughts on what are the challenges of implementation of quality 4.0 to a very specific, maybe top 2 point, though it is some aspects are touched upon. Mr. Periaswami.
I would, in our experience, I would talk about, there are a lot of challenges, and the top two, what we saw is especially on the aegis process and to be process. How well we spend time, how much we spend time, and do we deploy the best resources in building the to be process? Otherwise, we are likely to end up in, I think Prakash touched upon that. If you just digitize what is available, then we'll not end up in any of the clearer or newer objectives towards what we want to achieve. So the key challenge is how well we are defining the to be process. That is very, very important.
Okay, thank you so much. This to be processed. Before I come back to again to you, Mr. Prakash, I'll take one question from the chat, then I'll come back to you. There is a question from Mr. V. Sriram. He says, the way large organizations have driven IoT and Quality 4.0, progress in smaller organizations are probably not encouraging. Smaller organization is not encouraging. Any thoughts on how to encourage the?
I understand the question.
Yeah, please.
I just touch upon, I think this in my explanation also I touched upon, whereas log organizations, the commitment to the various new technologies and those things are very recognized by the large organizations, and also they have the power of both all the resources, money and all that to actually start doing it. While the smaller organization, I think directly referring to the MSMEs, I can say that they still are not in a position to recognize the benefits of the of this Quality 4.0 in the shortest time. See, I think the challenge for the small organization is that the time and the investment. I think in this respect, I think this question, in fact, it is not only asked by Sriram, it is also asked by the Government of India, which is trying to say that how to accelerate the Industry 4.0 vis-a-vis the Quality 4.0 also. So I think it's a challenge. So that's why we said it has to be a little bit more standardized, and sectoral standards can be developed so that need-based the benefit, the benefit of the implementation has to be seen very quickly for small organization to accept it. So then only I think this will be more a success. This is my point. Yeah, I think.
Yeah, please, Mr. Periaswami.
I have one.
Yeah. Okay, Periaswami first.
No, just one point to add upon this cost of poor quality in terms of percentage of turnover is not visible in small organizations. If that is made visible, they will realize what they can save is much higher than what they are going to invest in this. So if someone can facilitate that, it will be really great. Then it will go much faster. This is my
brilliant.
Brilliant, right? That's very well answered. So
I just want to add here, Rabindra.
Yes, sir.
I think Periaswami hit the nail on the, as they say, that measurement in monetary terms of the current situation will motivate the smaller enterprises even bigger, more than the larger enterprise, because for them every rupee lost is a rupee lost in the bottom line. The second thing I want to touch upon, and in response to what Prakash said, is that the OEMs should do the hand holding of the respective supply chains. The reason I'm saying this is the boundary conditions of the quality delivery and cost is not just the supplier's headache. It is the receiver's headache of the OEM or tier 1, tier 2, tier 3 as the case may be in the entire chain. So if every part of the chain has a hub and spoke and handle the next spoke, I think digitalization has to be driven by the so-called upstream value chain, or rather I'm saying the downstream value chain, than the other way around. If you look at the MSME standalone basis, this will not fly even for next 10 years. I guarantee you. I visited many MSMEs. This is pata nahi kya usme fayda kya hai. The fayda has to be defined by the OEM for the tier 1 or the tier 1 for the tier 2 and so on and so forth. And that if it is monetized, as Periaswami says, we got a tangible method to go ahead with this. Yeah. And it could be not only automobile, it could be machine tools, it could be anybody where there is a link of suppliers and customers. Thank you, sir.
Thank you so much, sir, for giving your insight, and thank you, Mr. Prakash and Periaswami. Before I come back to you, and hope Mr. Sriram, you got a very nice answer from all the panelists. And I take one more question from chat, which is there. It's Mr. Venkata Kumar. He is from Tata Hitachi. His question is implementing digitalization at shop floors, especially related to manual works. There will be many practical challenges, especially utilization of data and data analysis. So please share your thoughts. I leave it to Mr. Prakash and Periaswami. Anyone can you take up?
I think Periaswami's example was an excellent example in that.
So would like to say anything want to add it? Mr. Periaswami?
Only one point to add is even see, one of the challenges of big data is the data quality, what goes inside. And all the data quality primary root cause is manual entries and manual measurements. So how much of it can be automated? Because today, if you see bearing pressing, the load, or every other parameter has got digitized in some way or other. I think it my understanding, maybe some 20-30% of the shop floor still may have that challenge, but many of the parameters have got digitized in, and there are mechanisms and instruments to capture that. So the more we become automated and digitized and capture the data directly through the machine or the instrument, to that extent we can be successful.
Thank you.
Can I add a value here?
Please, sir.
I work for a company in electrical industry with lots of manual operations. In year 2001, without changing any of the processes, without any automation, with a semi-automatic process, pneumatics, etc., every operator had a barcode on the wrist. Every job card had a barcode on the job card, right? The routing card. And every machine had a barcode on it. These are the small pneumatic presses. Manual operation continued a manual operation. I tell you, at that time, I didn't even hear about Industry 1.0 also. We're talking about 2001, year 2001. In a small hamlet called Pondicherry, making millions of electrical products. I tell you, we had to reach from 10% defective getting exported to zero defective. And I was the MD of the company, I had no choice. And zero defective in electrical products is a big challenge. But by tracing the machine, the man and the material, well, the material is in trays, small trays. We made small lot production and there is a barcode on the tray. So I tell you, on the variety of products, these are actually nothing but fuses, British standard fuses. I think even manual work can be digitalized and there is a huge potential that even without automation, we can get into this project. Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir, for nice examples. Without automation, with automation, that to a specific electrical area is a great example.
That's where the two pillars are coming.
Yeah, yes. Thank you, sir. Sir, just a follow-up question, Mr. Periaswami. We spoke about data and etc. Probably these questions to both of you. How long an implementation journey takes place when you speak about PLM and driven quality 4.0? So can you just touch upon this aspect?
Our experience at TVS Motor, it takes 18 to 24 months on a particular plant. But as I said before, how much time we spend at the initial phase to build a very effective to-be process, what type of equipment it will work in that environment matters a lot. So even if it is 18 to 24 months, 12 months to be spent on the planning process and execution in today's in availability of various features or facility or suppliers at India, implementation is not a big thing, but planning is more important, is my understanding.
Thank you so much. So planning is very, very important. The same question, Mr. Prakash, can you throw some light on this aspect from your insight?
Yeah, I think a big implementation, as Periaswami says, it requires that. But I think just to get the advantage of the, my own experience, my previous company, it takes just to implement some digitization and digitalization, these two aspects, not the transformation. I think Periaswami's examples were all transformation projects actually. So that takes about 4 to 5 months because you just do it on a sample pilot areas and try to see the benefits. Probably you can get it. I think these from these two aspects, I would say one could be a small pilot area to look at and see the benefits. Second one is a transformation which TVS has done very well.
So
Thank you.
thank you so much. I got both the practice on both the side, bigger implementation, small kind of implementation, right? You want to add something, Mr. Periaswami?
No, just I was just seeing there are two perspectives.
Yes, right. So I see in the chat box the questions asked by Sriram. He thanks both the panelists for clarifying. And I see message from Mr. Venkatesh. Thank you for giving the insight with what question he asked. And I also see to convey Mr. Devarajan sir is talking excellent presentation of actual application by Mr. Periaswami. So looking at the time constraint, we are ahead of, we are 5 minutes cross the time. So so we'll not take much more questions, and we'll stop it here. And I would like to thank both the panelists, Mr. Prakash, Mr. Prakash, for a nice presentation, sharing case study, application, and addressing your insight and taking up the questions from the discussion. I would like to thank all the participants to join this session and asking right question, and hope you got the answer. So with this, I like to hand over to, now we'll start the panel discussion too. And I request Mr. Chandramouli sir, the great experience, knowledge, and already he's spoken about his experience.
So we have to call Chandramouli as an encyclopedia of quality 4.0, industry 4.0.
I cannot even drive a bicycle.
And PLM.
So I would like to hand over to Mr. Mouli sir, so that we cover both the pillars to be the excellence to that. So once again, thanks to all of you, and over to you, Mouli sir.
Thank you. Thank you very much. Thank you very much, Mr. Rabindra Saha, Mr. Periaswami, and Mr. Prakash Ji. Whenever I say Prakash Ji, it's like Gandhi Ji. So it makes interesting. Ji Prakash, I say Prakash Ji. So on that lighter note, I think fantastic session. I think it has made my job tougher now, because we have to make our panel as good, if not better than the first one. And I welcome Dr. Devarajan and Mr. Jagannath, who has joined already. Jagannath Ji, thank you, sir. And Devarajan Ji, of course, is a walking library from Warwick University. And Jagannath is a walking library of the machine tool and electronic industry. So with these two kind of panelists, I am really humbled. And I would like to just give a small overview and then hand over the mic to them. Can I do that, Rabindra? I think Rabindra had to rush out, so he has gone.
Yes, sir. Yes, sir. Please go ahead, sir. Please.
Okay, so I think again the sharing and all I'll try. Now, MS Teams is very, very tricky one. Is something coming up?
Yes, it's coming up. You see your the PPT.
Yes,
it is in presentation mode. You can go ahead, sir.
Great. In MS Teams, you know, when this comes up, I can't see myself, but I know how I look. The smart and affordable automation. I said intelligent, but I just like to slightly modify it being smart. I believe there is a small technical difference between smart and intelligent in the literature, but suffice to say smart could be intelligent also. And before I steal the thunder from the two great speakers, I just want to give some small introductory remarks. Before that, we'll talk about the two great speakers. Is my slide visible, Dr. Devarajan?
Yeah, visible.
Is that photograph looking like you?
Maybe younger, I don't know.
Thank you, sir.
Yeah.
I think you are standing in a nice under the tree. Dr. Devarajan, BE Mechanical Engineering, MBA Industrial Engineering, MS Engineering, and Doctorate in Manufacturing Systems Engineering from University of Warwick, UK. Fantastic person. And he is our Senior Vice President from Bangalore Chamber of Industry and Commerce. Earlier also, he was Senior Vice President of the TVS Motor. So he had a double whammy or double dhamaka effect. And he has he was being awarded the prestigious Rolls-Royce Award for Excellence in Manufacturing Concepts and Implementation in United Kingdom. Fantastic. Fabulous. and is awarded a thought leadership by Automotive Manufacturing Solutions, UK. Working in TVS Group for more than 4 decades and currently heading advanced manufacturing and production engineering in TVS Motor, leads new product development, worked in setting up facilities, a press shop, welding shop, paint shop. I mean, the entire gamut of manufacturing subsystem of automobile industry. And earlier he had a stint in TVS Electronics and presently concentrating on new process technology, lean manufacturing systems, digital manufacturing. Wow. Is that real walking library of Industry 4.0 for TVS Motor. Other day we visited a bunch of people from BCIC. We were very delighted. I think September it was, I think. And TPM and JIT is like, he's close to his heart, and he has been implementing it from day one in his career. And he is a manufacturing committee mentor. He's also the mentor for our committee, 4.0 committee. Actively participates in National Institute of Technology of Industrial Engineering, right? NITI. And IMTMA, Machine Tool Manufacturer Association, CII, Confederation of Indian Industry, ACMA, Automobile Component Manufacturer Association, and Board of Studies in several engineering and management studies institutions. Welcome, Dr. Devarajan, to this panel discussion. I will quickly introduce Dr. Jagannath also. He's just going to do his doctorate. So I took the liberty to already pre-designate him as Dr. Jagannath. And he is heading a company called M2 Next as a Chief Operating Officer, which is originally conceived as a division of BFW, Bharat Fritz Werner, with 32 years of manufacturing experience in control engineering and various products related to that, with Fanuc and so many other companies, CNC, PLC, these are all like, he's synonymous with it. Jagannath is synonymous with CNC, PLC, servo, spindle, field sensors, optimal CNC configuration, etc., etc. Even though he was a marketing person, he was so erudite on the engineering aspect of control systems. And we interacted with him in many, many forums. And he has worked on many machine tool companies, machine tool products, and right now handling the automation, along with the robo, Kobo, gantry, etc., with digitalization and remote monitoring. Underlying digitalization together with automation. And he's a very interesting specialist in automation of not just machine shops, but die casting, forging, welding, press line, injection molding, painting, etc., which are called the metal forming industry. Metal cutting industry is very famous. Prakash ji is part of that. Industry 4.0, data acquisition, bus protocols, 3D printing. Wow, that's another subdivision of his. Welcome to Jagannath ji, and he is the second panelist today, right? Before that, a very quick brief for me. I mean, Rabindra, anybody can ring the bell if I exceed the time. Automation applied to an inefficient operation will magnify the inefficiency. Thus spoke Bill Gates. I don't know to say who is Bill Gates, but his statement is a very important communication, message to all of us. Let us first improve the operation first. The foundation is extremely important. As Periaswami said, we have to also look at the new processes before we digitalize them. So inefficient operation obviously should be eliminated. If you can improve the operation, even well and good, then you do automation. It's a fantastic thing. Why automation? Just for very, very brushing up kind of concepts. If there are dull jobs like tightening of a tire in a truck line, my good old days, 1979, the human beings were tightening it. Dull jobs, dirty jobs, lot of dust, welding shop, etc., etc. Difficult to handle, very heavy weight, front axle beam, rear axle beam of an automobile. People are lifting 30 years back now. You need automation for that. Dangerous jobs where, nuclear related manufacturing I've seen in BHL and other places. And above all, when the COVID has hit us, pandemic, we have the distancing, social distancing. So these are 5 Ds, which beautifully summarizes, right, why automation is important. I borrowed these 5 Ds from Universal Robo. So I thank Saugandh to permit me to use it from time to time. Saugandh being the country head of Universal Robo. Now, other way of looking at automation is an effective way of improving overall equipment effectiveness. Has my slide moved, Jagannath?
Yes.
OE is improved by automation. Slide is moved. Very good.
Moved.
Very good. I don't want to elaborate this slide, but suffice to say, whether it is the machine availability, equipment availability, or the productivity of the machine with respect to the cycle time committed, or the quality coming out of the machine or the equipment, the overall equipment effectiveness is a product of availability, productivity, and quality. But in the event when these are all at 75%, 80%, and 95%, for example, if we get only a 57% overall effective, I'm just taking a pointer, you get 57% only the product of this three. I have taken a very high level of quality rate, 95%, because even 5% defective is dangerous for any organization. On the other hand, imagine if all of them are 90, 90, 90, you still get some 72% or something. Yeah, 90 into 90 into 90. Unless you reach 99%, 99%, 99%, you are nowhere near the target of 100%, right? So OEE can be improved by automation. Quality consistency should decouple from human fatigue and errors. Productivity should be deployed to eliminate all idle and handling times through automation. And finally, by decoupling the workers and their mistakes, yeah, and also the maintenance problems, we can bring in predictive maintenance or other concepts, and availability can be tremendously improved. So all the three goes to improve the OEE. So I would say, I think affordable automation is one subject, but even automation itself requires to look at it. This is a very elaborate chart, but very important to understand that automation has got elements, automation has got subsystems, and automation has got a complete systems. The elements being mechatronics, PLC, CNC, the systems being subsystems being robotics, cobotics, etc. But an entire factory, when it is connected and automated, together with smart enabled system like cyber physical system, which Jagannath will explain in great detail, we get a complete industrial automation as a pyramid. And I just want to close with last couple of slides, because there are more to be told by Devarajan and Jagannath, is appropriate automation for the Indian context. For the Indian context, especially for small and medium enterprises, should look at only the essential requirements, affordable requirements, simple requirements, and interconnected, interoperable requirements. This is a jargon, interoperable. I'll explain that. What are essential requirements? Only use necessary technologies. Don't try to use buzzwords like artificial intelligence, blah, 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 and try to get into technology-driven wish list rather than benefit and value-driven wish list. Use only necessary technologies and don't over-specify the requirement. Like it happened in any product, it's true with even digital products. Affordable. If the company is 1,000 crore company, spending 1 crore is nothing. If it is only a 10 crore company, spending 1 crore on digital technology is a very big ask. So the company's finances is extremely important, obvious point. But more important, not also obvious point, is a point made by Periaswami sir. If the cost of quality is measured by smaller companies, also when you spend 10 lakh rupees on digital technologies and automation and you get 20 lakh benefit in cost of quality, straight away the project flies. But you need to measure the today's cost of quality before you implement the technology investment to see whether the benefit is really worth it. That's the meaning of the word affordable. Two dimensions. One is budget should be there. Number two, cost benefit analysis should justify that. We call it feasibility analysis. It should be very simple, easy to install, easy to maintain, easily operated by the operator. Three important things. Many people missed out these points. Easy to install the automation, easy to maintain the automation, and easy to operate by the operator himself without depending on the maintenance department. And interoperability is across the factory and within the shop floor of every factory, every division of the factory. Can we connect regardless of the brands of machines and whatnot, right? In a brand agnostic situation, can we make this automation operate across various types of products, turning center, machining center, presses, hydraulic presses, welding, etc., etc. But a platform can be commonly utilized. A gantry can be commonly utilized. A robotics can be commonly utilized. And that's a very important requirement for making it appropriate and affordable. And then to summarize, appropriate means smart sensors can be very, very low cost appropriate sensors, appropriate IoT and edge devices, appropriate small data processing. Don't get confused with big data concepts. Go for small data processing. There is a concept called small data. Even our normal Excel is enough for doing analytics. Appropriate vision-based monitoring. Flexible automation using cobos. You don't need a big robo every time. Put a big fence and all. A cobo which even a human being can touch becomes a fantastic automation. And above all, augmented reality for remote monitoring of maintenance and after-sale service. Right? This is just a visual explanation of an expensive robo. I mean, nothing against our good friends Fanuc here. It so happened the Fanuc robo is yellow color. And coming to the universal robo, it's not in favoring universal robo. Just two examples. Expensive cage robos are rigid in nature and very flexible and affordable collaborative robos. Of course, we also need these robots in many, many dangerous and difficult to maintain areas. But faster adoption, easy to learn, zero maintenance and flexible installation and redeployment are very, very important lessons to be learned when we choose the automation. More of it will come from Mr. Devarajan and Mr. Jagannath. So I close here and Q&A, etc. I'll come back again. And with this, I would like to hand over to Dr. Devarajan. Over to you, Dr. Devarajan.
Thank you. Thank you very much, Chandramouli. Thank you.
Followed by
to share
Mr.
my.
Jagannath.
I think you need to. I need to share my presentation.
I unshared.
Yeah. Okay. Okay. Yeah. Yeah.
I hope I was on time.
Yeah. 1 minute.
Now, Devarajan sir,
check my.
If you can
Yes,
finish
sir,
if you can finish in 20 minutes and Jagannath in 20 minutes, we can take
yeah.
more questions.
Yes. I'll try to get my 1 minute.
Even I have some fundamental doubts on this topic, so I also would like to ask some questions.
Yeah. 1 minute. I need to take my presentation. Just a minute.
Yeah. Please. Take your time.
Yeah. Sorry.
Wow, we can see you also.
Sorry, I'm trying to get my presentation. Sorry. Is it visible?
You go on to the Teams chat. First, you have to open the presentation. No, you have to open the presentation. Go to the window that has got the presentation. Close all other windows. And then that window only you can open. Yeah. Please, you opened a wrong window now. You opened a window called Teams chat. You have to open the window called presentation.
Sorry, 1 minute.
Yep.
I'm trying to share.
Yeah, go to share. Have you opened that file? Have you opened the PPT? First, you must open the PPT.
Yes.
After opening the PPT, you go to share and it will show many windows. You click the wrong window.
You have to share the presentation.
Anybody can help you?
1 minute.
Periaswami sir is there.
Share.
Anyway, my tea has come. I'm enjoying it. அது முதல்ல ஓபன் பண்ணிக்கணும். அப்புறம் தான்
okay. You're able to see?
No, not yet. It is still the list of PPTs. You have to double click it. You have to double click the affordable intelligent automation. Yeah.
Already double clicked.
First, you have to come out of that cursor. You first come out of the cursor. You do one thing. First unshare.
Yeah, now it's okay.
Sorry. First unshare karo. Unshare pannittu and the file open pannittu, then you come back.
Yeah.
See how difficult is digital technology even for a large OEM like TVS Motor.
Sharing okay.
இப்ப வந்து அந்த அத முதல்ல ஓபன் பண்ணீங்க. ஃபைல் ஓபன் பண்ணுங்க. வராது.
I'll go back now.
You please unshare, double click and open the file. Then you go to the window where the file is opened. I told you, digital technology difficult even for OEMs, not only for MSMEs. On the lighter vein. Aha.
Share it. Stop sharing. Share. Let's see. Yeah. Yeah. Okay. Sorry. I think I got a
OEMs also have to learn
digital
digital technology. Okay, go
Sorry.
ahead,
Yeah.
Dr. Devarajan.
I'll try to, sorry, I'll try to.
No problem, no problem. See, at least you are lucky to have Periaswami next to you. I don't have anyone.
You're okay
around
now,
you.
we're able to see?
Yeah. But you have to open that now. Perfect. Wow.
Okay.
Excellent.
Thank you very much. Thank you, Periaswami. I think a lot of information was shared by both Periaswami and Prakash, and definitely by you. I will try to touch upon this slide. Shows that left-hand side, what was the Ford automation which came into picture. That was a major area in which everyone said Ford has continued and made the mass production start. But we can take Ford car as long as it is black in color. From then onwards, all the varieties have come into picture, and today's world is moving towards additive manufacturing, subtractive manufacturing changes. In this context, how will you get into automation is my topic. Why is the major requirement? So when the quality changes, like what Periaswami did mention, it is becoming zero defect now. You're able to see my cursor? You're able to see my cursor? Is my voice clear?
We are clear with your voice, Dr.
Okay.
Dr. Devarajan.
Okay. Yeah. I'll try to get the
voice as well as slide also is clear.
Yeah. Okay. Now we change from the quality from percentage to zero defect. And in terms of the requirement of the customer, giving the perceived value to the customer, including the PLM and other automation. Most important thing is you have changed from QCD, the quality cost delivery, to quality cost timeliness. To ensure timeliness and quality, we require consistent process, which are flexible, traceable, delivery at affordable cost. This is the core in which all the automation, the cost of manufacturing comes into picture. So the drive is through the customer in terms of the quality, in terms of the time, and we should be able to have traceability in our areas. So with this context, we have to go into level of detail today in terms of from the machines to methods to part handling to the fixtures to the equipment, the tools which are using to the type of cleaning. In terms of automation, we have to ensure that these things are in control, because we normally say automation can be easily done, but we have to go to every element of automation, every element of machine in terms of the fixtures, in terms of the tooling, in terms of handling, in terms of adjustment, in terms of the measurement. So it is a wide scope in which the management systems is composed of. So what is affordable automation? According to me, is a technology which increases the efficiency of a person with some degree of automation around the existing equipment, tools, methods, people, making the standalone equipment using majority of standard equipment available in the market. We have to be at very, very low cost and ensure that we are talking about affordable. But what is low cost? If 1,000 is low cost, 1 lakh is low cost, 10 lakhs. But according to me, it depends on, it's more than how fast my LCA will earn back the invested money. Whatever be the money, how quickly you're able to get back the money which has been invested in automation will result in the benefit. Normally it's measured in terms of return on investment. Even if the investment is higher, if the return is within the month or within the 12 months of usage, it is considered as low cost, according to me. So it's important not the overall turnover, it's how much benefit the investment which you have made for the automation can get back into the benefit of the company itself. So, like what Chandramouli did mention, we normally focus on dirty, dangerous, difficult job. Very, very important is that we focus on these areas to make the work easier. The reason I mention is, who is the customer? Normally, we talk customer as the person who buys a vehicle. The customer is a OEM for you, is an MSME. According to me, the customer is the operator. How to make the work easy for the operator, how to make the work better for the operator, how to work on the economics of the operator, because he is the person who turns in the product day in and day out. So the first is the focus on the dirty, dangerous, and difficult job. Second is we have to really have a benefit in terms of the risk and the budget. Suppose you have a risk of low risk, and in terms of high risk areas, we have to select between the low cost automation, semi-automatic automation, and robotic automation. Similarly, if there is a repeatable job or if the manual interference is very, very low, then if the budget is high, we can go for semi-automatic or robotic or automatic automation. So we need to have a very clear indication when we present to the management the benefit and why we are trying to do this automation. With this in mind, with a focus on dirty and dangerous and difficult job, let's go to the importance of it. One thing I find is it costs approximately 400 times as much for a man to supply 1 kilowatt energy that it gets from the electrical power. So we need to ensure that we cannot use person. We can't use person as a source of energy. Utilizing human being as a source of energy is a very, very inefficient way. We have to use him as a resource for us, not as a person who can do loading and loading and as an energy purpose of clamping and other areas. So we have to improve the efficiency of semi-skilled and unskilled labor with very little training. So this is an importance of affordable automation where we want to do. Similarly, definitely we feel the consistency improves the quality level, reduce the man fatigue, and definitely improve the automation of the existing processes, improve the OEE, like what Chandramouli did mention. And we can't use operator for sensing, checking, visual indication. Definitely we can use a better resources in terms of automation and in terms of vision system. That's the area in which TVS Motor we're trying to do across India. So one video I'll show, just 2 minutes, if it plays. So this automation, it shows how we are using the people power itself. And step by step, it's 2 minutes, I'll try to run it through. So this is one example is on the ball packaging itself. So we were using a lot of in our various sizes, in our spares. And this is a way of initial work which has been done, counting and placing the ball manually into the area. And you can see a lot of mistakes happening in terms of missing, falling down. These are the type which were earlier when we started. So definitely we need to capture the current stage very, very clearly. What is the current area? What are the areas of difficulty in any automation you do? I go from the simple example in this case to the final example I'll show in the next 10 minutes my time. Then we went for the second level of automation of ball packaging. Simple spatula used, the different sizes. And we find the benefit of using the people power, people energy, people idea to use the automation. Very simple automation again. It counts the number of this thing. Again, there are problems, but this is the area in which you can also do. No major investment, higher benefit. But again, there are problems in this case. So different spatula for different sizes was used, and then we changed the next method. we went in for the very, very low house automation, which is hardly built in our company. So we started making our own idea based on the pneumatic controls, based on the sizes. This we found is much more consistent and easy for the operator. Many of these automations we find, if you involve the operator, if you involve the engineer, we can get at a very, very appropriate cost and able to use it fully, because we can't bring any automation from outside and say this is the way to do the work. Just made in our tool room, and many of the applications were simple in terms of pneumatics. Then we went in for many of the auto pick and place. I just want to mention this because the same principle is used for press shop also as we go forward, using vacuum and other areas. This is for pick and place. So same method used for our plastic covers, and I'll show you the press shop, the similar examples. It uses the demo as well as the production. So sorry, I think I'll go to the next one. So we said we will go to what are the affordable automation? According to me, the majority of this is to understand what are the customer pain points. Visit to the Gemba, understand the current situation, capture the customer pain point. This is the most important thing in any automation which we do, including to the digital automation or affordable automation. Next is based on which we can have either the fixed automation in terms of repetitive work, make the work easier for him, load and load area, using sensors for okay. Low power or no power like Karakuri. This is the second way in which we focus on fixed automation. Then came up of linking the existing control system as a programmable automation, which we went through in the steps in TVS Motor, and make it much more flexible, multi-model, take the machine details, sensing the temperature, vibration, preventive and predictive. So we can go from making the work easier, linking to the current PLCs, and making for the flexible automation. The most important thing in an affordable automation is how to make it flexible also along with it. So the next is, if you go into the intelligent automation, we went in again, going to the customer pain points, like just all the benefits of what are the pain points is getting and listen to the customer, and then going to capture the current information as the project discovery and mining, using sensors, RFID, party sensors, vision camera, very low cost vision camera, trace through barcode and RFID. I'll show some examples of this. But majority of thing is involve people, engineering, operations, maintenance, optimize and sign off for the thing. This will give you a very clear way of intelligent automation. Then how to get affordable intelligent automation? Again, we have to ensure that the customer pain points are seen, understood, Gemba, Genchi, Gembusu, areas of capturing the customer pain points. Focus on all the 7M conditions. Make the work easier. Method, make a very, very simple steps of areas. Material, easy flow of material for the Kanban pickup areas. Manufacturing cost as low as possible. Material handling, measuring, and definitely Mother Earth, Karakuri, reducing the amount of power requirements. Focus on all the 7M conditions. And as much as possible, link existing control itself to make it easier. Even when we talk about our supplier, we try to make it very, very simple and get the benefit of all the 7M conditions: material, method, manufacturing, cost, material handling, and make it as flexible automation, especially the vibration analysis of the spindle. There we may have to invest a little bit more, and multi-model and fixture itself is designed in such a way that you can have multi-model, able to identify which model and which program it has to run in. So it becomes affordable, at the same time intelligent automation. So some of the examples I say, some of these areas are DC tool, nut runner in our areas, tightening sequences control. Only the particular sequence is all built in-house in the area, and try to use robotic change based on RFID number, consistent tightening torque, and we have already 24 assemblies in our 24 robots in our assembly, integrating IoT and capturing the tightening torque against the engine number. So whatever we do, ensure that it is traceable. And some of the cobot we are used from the both cobot and robo we have used, and DC nut runner, because the consistency of tooling is very, very important. Similarly, in terms of vision system in terms of the identifying the right wall to be assembled, and ensure that the sequence of assembly, sequence of tightening, positioning accuracy, and of course use the force sensor to capture the data in the watch assembly. So we are able to capture the information about the model which is running, and the assembly sequence and the tightening torque as well as the force is required. Similarly, a lot of vision sensor. Today, the cost of vision sensor has come down drastically. So majority of use can be used for checking the kitting part of which model, because we normally make 10 to 12 models in the same line, and the cycle time is something like 24 seconds. So we have laser sensors for cotton pin position checking. RFID is a must for all the component. It reads the model which is going to be assembled on, integrate the engine with a pallet, and capture the engine quality consistently. So we can go from vision sensor to laser sensor based on the requirement, and make it simple, make it affordable, and make it done by your own company. So they'll have a much better benefit of the benefit what you see from the quality level. Similarly, we found an integration of both vision, robotics, and of course, sometimes we find in the sealant applicator, if you don't use this applicator, a lot of wastage is seen, and a lot of sealant remain in the engine part itself. So we are able to use the vision system to have zero defect at that particular station. It's very important that we measure the quality level of every automation we make. Okay, this is another example. One example I saw yesterday in one of the YouTube. I'll try to work. I don't know whether it will see. This is for the, and we are trying to work on. We are doing a similar example of vision system for the paint. This I got an example from the car of ISRA Vision, and optical.
You cannot click the YouTube link. You cannot click.
And this we find similarity. We want to use it in our paint quality level, which will ensure the quality consistency of each and every vehicle it has been made.
No, Devarajan, you cannot click the YouTube link. You have to download the YouTube in a window, and that window you have to share.
The type of defect, if it is seen, and the improvement point on the measuring quality.
Dr. Devarajan, I think, can you hear me?
Fit and finish gap in our area. So this
I think Dr. Devarajan is not able to hear. Can you hear us? Dr. Devarajan, you're not able to see the video. Can you hear us? I think there is some problem.
Really, we find, apart from automation, we are able to control the operator in terms of the digitization of the work done. Normally, the operator notes down the leak value in the leak tester, post the engine in the posting state to the test rig, and write down the engine number. All are manual. It's done earlier, last 40 years, the engine number. And now we have changed to implement system to capture the leak value against the engine number. Have the face recognition for the PC to capture the operating details. Test OK or not OK from the operator to the server. And system to detect at the same as the PC we are able to implement. And we find that there are a lot of benefits in terms of capturing the engine leak value to the oil filling quantity. The test rig scans the engine number. If the leak is okay, and only the test rig will start for the multi-model. If all parameters are okay, then the operator declamps. And we find we also measure in terms of SMS saving and in terms of FQI measurement. So in this presentation of mine, I try to capture what is automation, how we are able to implement in our local automation affordable, and linking even to the paperwork which can be done in the factory. Secondly, we found that the benefits, the customer pain points are the most important thing, how to make the job easier, how to make the work consistency in terms of the output. The benefits is consistency of output. And rework reduction, right first time, every time is and traceable. The confidence building of the team itself goes up in this automation. And team involvement is very, very key for our success and sustainability. We find that the good process will give you good product, will give you an excellent team, which retains the customer to sustain customer benefit. The customer benefit is in terms of ROI. We have to capture the end-to-end calculation and cost of poor quality too. Second thing is, if it is not done, what will happen? Capture the risk. Today's world, to survive, we have to automate. Thank you.
Thank you, Dr. Devarajan. That is a brilliant and very, very crisp presentation on affordable automation. Are you able to hear me, Dr. Devarajan?
We can hear you, sir. I think he's not able to hear.
Some problem.
Thank you.
Kekarda, are you able to hear me? Devarajan? Devarajan, sir, are you able to hear us? Wow. Anyway, Jagannath is open. Welcome to Mr. Jagannath. But Devarajan should, Periaswami, please help Devarajan for the audio issue, because when the Q&A comes, whether he'll be able to hear the questions. Okay. Dr. Jagannath, please go ahead, sir. No, Jagannath audio, I'm not able to hear also. Jagannath audio.
Not audible.
We can. No,
Yeah, now
not
you're
audible.
able to listen. Yeah.
Jagannath, now Devarajan okay, but Jagannath audio? Jagannath, I cannot hear. I can't hear you. MS Teams is playing games.
Not able to. Jagannath muted.
We cannot hear you, Mr. Jagannath.
Is he muted? No, he's not muted. No, sometimes this problem happens. I had the problem, when I started today. Jagannath, what happened? Sometimes you have to re-log in. Jagannath, we cannot hear you. We cannot hear you. The MS Teams has got a problem like this. We cannot hear you. Yeah, and I want to tell, okay, thank you. Disconnect and connect, please. Jagannath, sir, what we are telling, you are not able to hear. You may have to disconnect and rejoin. Because Q&A, you will not be here. Thank you, sir. We cannot hear you, sir. Thank you, sir. Thank you.
I'm okay now.
Jagannath, I'm admitting him back into the pavilion.
Is my volume okay?
Devarajan, are you able to hear
we are
us?
able to hear you.
We are able to hear you.
Okay, Devarajan, don't switch off. Both of us are able to hear each other. Jagannath, problem. I had the same issue when I started, but then I logged out and logged in. I think
I suggest one point. This is Prakash.
No, Rupa may be having two settings. One setting for participants and one setting for speakers. So if you log into the participant checklist, it will be a problem.
No, sir. Mr. Jagannath is in the present. Is one of the presenters only. Audio and video is there.
When you logged in now, you might have used your normal link rather than the presenter link. Jagannath, now video also is frozen. Your video, audio, both are frozen. Yes, we are admitting you back. Maybe it's a speed of that internet. Only on the phone. Not on the. And I see two devices you are connected. I'm getting two devices.
So is the volume of your laptop increased to the maximum, sir?
You mean Jagannath or mine?
Jagannath, Mr. Jagannath.
No, Jagannath is doing so many such discussions with customers and all. It must be a special problem. When I started also, I had a problem, Rupa. Do you think it's got to do with the BCIC platform?
No, sir.
In the settings, you must be careful. What you set for speakers, what you set for participant. Can you check the settings?
It's common link, sir. It's common link. Only for the participants, we make it as we mute the audio and video. That's all.
Correct, because Jagannath is shown under presenter. Correct. We are all in presenter. Attendees are in separate. Oh God. I think he has got a deputy to help him out. Meanwhile, I requested all the participants to type their questions to Devarajan. Do you think we should take the questions of Devarajan and then jump to Jagannath when he's ready?
So they will have time. Yeah, we can.
Jagannath, we are going to take the questions for Devarajan. Nobody has put any questions there. Is Jagannath still successful, or should we start with some question for Devarajan? Shall I start with some questions? Jagan?
Yeah, I think go ahead.
Jagan is still struggling. Jagan, why don't you reboot your computer?
Chandramouli, any questions we can discuss on?
Yeah. Are you able to see the question, Devarajan?
Yes.
First question from my side, since audience not asked any question. How to implement affordable automation for MSMEs Maybe you touched upon it, but if you can elaborate, it'll be nice.
Yeah. The most important thing for the automation to succeed for MSMEs is working along with OEM and MSMEs. Because we have to ensure the participation level of the MSMEs towards automation is getting benefit for themselves and for the OEMs. Finally, automation is definitely for reduction of waste. So once the wastes are getting reduced in terms of whether the over processing or in terms of the extra manpower required there or in terms of the rework, if you reduce, there's a benefit for the SMEs themselves. So if we have to go to the various steps in which we have to work along with MSMEs, we have a supplier development team and we have a team which works along with the MSMEs. And it's not only for automation, it has to be on the overall benefit in terms of how you're able to deliver the requirement on time. Because today, N is equal to 1. Every customer is different for the OEMs. For the OEMs to deliver to what the customer requires, he has to have a good production facility inside as well as supplier facility outside. So it has to match. So it has to be a win-win situation. And secondly, it has to be affordable. I agree with what
affordable.
It has
How to make it affordable.
It has to be a benefit for cost also, and it should not be overboard on sensors and information. So we have to go to the customer pain points. What are the areas in which there are problems? Where are the areas in which the flow is important? The process flow is important. The good process will give you good product. So good process flow is important. So some amount of working along with the operator, along with the engineer from the beginning itself will be important. Second thing is there is a requirement of the design of the product itself. So many of the OEMs which is designed for automation itself, designed for easy automation, designed for easy and removal of the component, designed for ergonomics. So there's a part for OEMs, there's a part of SMEs together or the supplier. So it is a joint effort and we have to go in steps and there is no short route. According to me, definitely when they see benefit of usage of this automation, further demand will come, further requirements will come. They just grow in the organization. They just grow in.
So that is the experience of TVS Motor?
Yeah, see, TVS Motor, what we have done is definitely we are working along with the suppliers, working along with them. And not that everything should be handholded. There are many suppliers who are very good, like Bosch and other people are very good. But some suppliers, definitely in terms of fabrication, in terms of the painting, in terms of the machining.
Only MSMEs we are talking.
Yeah, work along with the MSMEs for fabrication, work along with MSMEs for our press shop requirements. So it is a joint effort and it will succeed only when there is a combined working together. And it can't be forced. You have to automate. You can't do that. They should feel the requirement of the benefit for themselves and to the company. Secondly, we have to ensure that the MSMEs also have right engineers with them. We may have to have the skill sets. We have to work along with them to ensure that they have the right skill sets, and the people involvement also is important. So are we ready?
There I would like to debate a little bit.
Yeah.
See, the creature called manufacturing engineer is so expensive, MSME cannot afford it. So I think as part of your vendor development team, manufacturing engineer should be in TVS Motor salary payroll. And only the technicians can be at the MSME payroll.
See, what we normally did is some of the machining areas, we already established the facilities inside. We are able to move it to the supplier and ensure that they use the requirement as per what we have designed to. Secondly, fabrication area. We ensure that the engineering is done in a company and then along with it. So it's a long journey. It's a long journey in which there's nothing like which is the best one, because it is a combination of requirement for both. And any automation, you have to apply for all the 7M conditions. Don't go only for automation for productivity. Ensure that the quality improves. Ensure that the working is easier. Don't see that I've done only automation and it should give benefit. Unless the
that brings me to the productivity when you mention. I hear many people talking about automation is to reduce manpower, to displace employment. But some people say, no, it increases employment. Can you just resolve this paradox, whether it reduce the employment or increase the employment?
The type of employee skill set changes. The type of the enhancement of the skill of the operator changes. The view of reduction of wastage is seen very clearly by the automation. When the work is made easier for him, he can deliver a better output. So it cannot be seen as displacement. It is to be seen as an enhancement of his skill sets, enhancement of his work, easy for him to do the work.
But don't you think when we get more work into India, away from China and other places due to automation, then the overall employment also goes up? I believe now auto component industry has grown 38% year on year.
The volume increases, the work also increases, the type of work will change.
No, volume will increase only when you do automation. See, it's a chicken or the egg.
It has to. I strongly believe unless you automate only, you will survive. At the current cost of having more and more people, you can't be asking people to do the work which is mundane in nature. We can't ask him to do inspection which is mundane in nature, which will never be a benefit for you. So we have to make the change in which the type of work which will help the operator.
And especially in export business, auto component export business, Devarajan, it is absolutely essential to match with the European and American standards.
Secondly, you don't have business if you don't have consistent quality. You may have 100 people with you.
Standards and quality, I mean. Yeah,
absolutely. So it's very important to see that there's a benefit. It will definitely displace the mundane activity, but it will improve the skill sets of the people, improve the benefit for the people, both in terms of the business of the company, as well as easy for the operator, ergonomics is concerned, consistency of quality. And when you're talking about benefits, if you're able to get a payback within a year, the company also will be forthcoming in giving more and more automation to you. You can work lights off if it is a small operations. The cobot can work along with the operator. You can lift heavy components and give it to you. It's very easy for you. So it is how you are able to explain to the operator, how you are able to explain to the workforce. It all depends upon the management and ourselves to make it happen.
If Jagannath has already come into the Jagannath, audio is okay now? Jagannath, audio okay? If not, the third question is, can you illustrate how you handled the vendors to adopt the Industry 4.0 technology? Can you illustrate with an example?
Yeah.
Actual example.
See what I can take one of the example of manufacturing of crankshaft. We were doing the manufacturing of crankshaft inside a plant. Now we are able to work along with one of our suppliers who set up the plant nearby our place, nearby our factory. And in terms of the crankshaft is a very critical part in our engine, the most critical part of the engine. So in terms of the machines selection, in terms of the data capturing for the machines, the mud was into the finishing, you are able to work along with the suppliers. And today we have reduced the rejection rate, or is almost like a zero defect quality level, multi-model, multi-area. We have worked along with the suppliers, and you can have probably visit a supplier when the team visits in our place. It has gone into all the 7M conditions: the machine, the fixtures, the measuring instruments, material handling, the traceability portion of it, data from him in terms of the data to us.
So you have a real life case study.
Real case
where
study.
BCIC members can come and see that the supplier of TVS Motor has implemented with the help of TVS Motor.
Yes, I will ensure that the supplier themselves make the presentation and show it in their plant.
Great. So we will do it in January or February.
So that's maybe better to do rather than saying this is the way we have done. Similarly, we are trying to do with the fabrication. We are trying to do with the other areas of work. Okay.
No, you can show 2-3 examples. We can have a tour around that Hosur area. But Jagannath, what is he having? Sound problem. Jagannath's face is little sulky. Jagannath, can you do it on your mobile phone? Jagannath, you log into mobile phone. You show the
Voice.
slide in this.
Voice.
What you
Yeah,
do, Jagannath, you show the slide in your other laptop and do the audio in your mobile phone and switch off the audio in the laptop. Otherwise, there'll be echo. I don't know if Jagannath is able to hear what I'm saying. You just show like this. If you're able to hear, thumbs up. And audio in your mobile and that PowerPoint in your laptop. But audio in laptop should be cancelled. So I saved some time by the Q&A to Devarajan. There are some more questions. Devarajan has come. Until Jagannath logs in, Prakash G is asking, is India ready for high level of automation? Oh, Jagan is coming in with the other device. This is a trick I did once.
Hello.
Yeah, but you must switch off the audio of the laptop.
Yeah. Now is it
Great.
clear?
Yeah, Jagannath can now go ahead with your PowerPoint, sharing PowerPoint in laptop and audio in the mobile phone. But ensure mobile phone has got enough battery.
Okay. No
You
problem.
must switch off the audio in the laptop, not both.
Hybrid.
Yeah.
Hybrid mode mat karo, either petrol or electrical.
Banta. Hello.
I'm not saying diesel because it's banned anyway.
Hello.
Screen has come and he's talking in the mobile phone. See how digital
Yeah.
technology can be made flexible automation, it is called. All right, Jagannath, go
Sir,
ahead.
is the screen on the presentation mode?
Screen is in presentation mode and you are visible, you are audible also on your mobile phone.
Okay. So I'll quickly, we have wasted a lot of time. So we just come into all the topics what we discussed about the difficulty, dangerous, dirty and all that. So I will just talk about two use cases today in terms of what is implemented and how the success has been measured. A classical two use case on MSME sector. It's not even SME, it is MSME. And let me take you through. Sorry. So we just do, everything in automation. So I'm coming to the most important slide, which is a pyramid, where, every end user needs to understand this, if not, get into the expertise. So today we are talking of what kind of, just a minute. So we have the edge layer where we have all the equipments. Then we have the field bus protocol layer where we talk about Ethernet-based field bus, serial-based field bus, and legacy protocol. Then we have the MES layer, and then we have the ERP layer. So if one understands this and starts making, plan in order to go from shop floor to top floor, which is not going to be very expensive, which is not really unaffordable for MSME, you could really integrate all these, layers one after the other in a planned manner and see that how do you take the best benefit out of the entire automation implementation. While you digitalize the automation, you also digitalize the equipment on the shop floor. So the next, two use cases. The first one, let me take you through the digitalization and automation in ladling. So as you can see on the screen, the traditional method has been that an operator usually does the most dangerous and the dirty and the difficult job by, carrying, the molten metal in his hand with two people on either sides would pour. So we did this study and the customer was very, very sensitive towards price. So he said, he just gave us a target price saying that if you meet this price, for sure the order is yours. And if it successfully works, the repetition of the order will continue. So what we did was, we just didn't want to do the automation. We also used our homegrown product called Iris, which captures the data. And we started, working on this subject. While we automate, how do we start giving the information to the topmost person of the company to see what kind of inefficiencies were, there when the traditional methods was followed, and how the rejection rates were there, which were not really very, very visible and not so transparent. So we went with this, architecture and started working. So it was a requirement of 4 GDCs with 2 holding furnaces. And the customer expectation was certain amount of parts to come out in the in a shift. So we designed and architected a gantry which was 4-axis with servo control, and the gantry lengths were very long. In terms of x-axis, it was 16.8 meters and z-axis was 1.3 meters. But we also gave a tilt angle for the gantry, so that when there is a difficulty in placing the runner in a line, there can be feasibility in terms of control, which can dynamically happen when the pouring happens. And we also gave a ladle swivel, because we didn't want to have any residue in the crucible, so that the crucible goes for a quick maintenance all the time. So we were thinking, how do we empty this? So we gave control on the ladle, we gave the tilt angle, so we could achieve the variation in the runner, and we could also pour the entire volume of metal by writing an algorithm on the swivel, so that there was no residue, and as a result, the life of the ladle became longer. So finally, we started working on this, and as you can see on the picture, we placed all the 4 JDCs in a line, and in between, in order to get the minimal moving time, we kept the holding furnace. And as you can see in the layout, this is how it was looking like. And from the side, when you look at the ladle, where I'm putting the cursor, hope you can see, one had the opportunity of changing the inline variation of the die when you load a new die, and the control of the ladle was handled by the servo. So this was the top view, and this was the control of the ladle. And this is the 3D view of the entire project. This was prepared much before the order was given to us. And the next thing what you can see is the most interesting part is we did a PDI. In the PDI, you can see that we did the trial using coolant as the subject, just to see what kind of volume picked up were there. And when we poured it back, whether the same volume was realized. This was one test. Second test was when we did the pouring, we did such a uniform pouring, we were very confident that the porosity rejections, which were like 30%, could be completely eliminated. So you can see the molten metal level was managed by an infrared on the top, which could sense what is the molten metal level, and the volume of material, what was picked up by the ladle, was measured before pouring. You can see that, after picking up the molten metal, it starts pouring it out. Now, this was the PDI, and let me show you a real installation. So this is the real installation where, the gantry moves on the shop and measures the level of the molten metal, and then it goes and picks up the molten metal, the real required volume, which is good enough for the die to have, and no residue in the ladle, so that the ladle life, which was in a way getting shortened because of the residue material, was completely handled and was not eliminated, but was minimized. So you can see how the scooping happens. The ram doesn't touch the molten metal. And you can see that now the measurement happens, and then with a tilted angle, the molten metal will be poured back, and then it will go to the gravity die casting machines against each requirement, where there are dual ladle to beat the temperature, number one. Number two is to minimize the pouring time, so that you have 2 ladles continuously working, parallelly working, so that the timing matching is not an issue. So the ladle comes here, and you can see that it will just pour now. So the material what is poured is of complete utilization. Here you can see that the residue, there is almost nothing in the ladle. So now this starts tilting, and then the gantry goes for the next pickup. Now let us look at the benefits 24/7 capability, remote monitoring because we had an intelligent device sitting and checking the heat batch, highest human safety, minimal layout changes, drastic reduction in wastage, 95% reduction in wastage and rejection of castings, no porosity, controlled pouring pattern, versatile based on different dyes, right temperature scooping to pouring within limits, adequate and programmable quantity scooping each time by a recipe, tracking of heat batch on the cloud instantaneously and data log with tailored analytics, optimal OEE achieved and easily accomplished just in time, increased productivity over 30%, committed deliverables, zero accidents and total safety for end of arm tool because we have a collision sensor on the ladle. So this was the first use case. So I go to the second use case, again on an MSME where digitalization and automation in machining. Typically automation, people think that large variants not possible and batch quantity and unanticipated batch quantities and variation is always a problem for automation. But we overcame this with again an MSME where we said that we will use little smart and intelligent way of doing this. So we again used the iris and took control of all the peripherals in the shop. And let me give you some description on the challenge. There were two varieties of gearbox, body and cover. To accommodate 32 variants, we were handling gearbox, body and cover on a single cell dynamically, and we had to accommodate 32 variants. And the total number of machines were 5, 2 lathes and 3 VMC. We also added an automatic part number marking after machining, which was one of the value addition to see that the return on investment will be much faster. Double-handed grippers, 3-shifted operation with 90% efficiency, manpower reduction from 9 operators to 3 operators, easy and quick setup change, auto tool offset correction, part feeding system with dedicated conveyors for body and cover. So you can see the variants. There were 12 variants in the gearbox body, which was foot mounted, 6 variants on the flange mounted gearbox body, and 14 variants of gearbox cover. Everything were to be handled in this cell. So we designed a 90-degree end of arm tool, which was able to handle cover and body. And you can see the cover was handled by an external gripper and the body was handled by internal gripper. And we gave different finger pads of different diameter in order to accommodate the variant, which was a quick change SMED concept. And the entire cell was kept like this with 5 machines and the robo in the middle. And we gave a setup change guidelines. When you operate a particular cover, what should be the finger he needs to use? When you use a particular body, what you need to change? So like this, we made a proliferation of the fingers with respect to the component which was run. And since there were some legacy machines, we also gave machine, auto tool wear offset correction on the HMI. So the operator could put the correction automatically. This would go into the machine through an RS-232 and then connect, get compensated so that there is no requirement of going and touching the machine MDI at all. So this is the video. This is a brownfield again. First, this thing also was brownfield. This is also brownfield. Different machines, non-BFW and various Indian machines which we integrated. And you can see that at the 90-degree, there is ID and OD holding capability, where you can see that all the operations are happening with different part presentation using a conveyor. So coming to the benefits, 32 variants, committed deliverables to the customer. The customer started exporting after this. Reduction in rejections because of remote monitoring of the automation cell. And then 66% reduction in skilled manpower, very important, deployment of them for further automation improvement feasibility. Okay. And safety for human and machines. And tool life management, auto tool offset. So I end my presentation here with a quote, one who can't determine his goals cannot win. Thank you so much. Hello. Hello.
You are audible, sir.
Yeah. So I think Chandramouli is not able to hear, I think. Hello?
We are able to listen to you.
Yeah, I ended my presentation. Chandramouli?
There was a question by Prakash. I think Jagannath, you can answer whether we are whether we're ready for heavy automation.
Is
Hello?
India ready for high level
Yeah.
of automation considering
Jagannath,
the labor cost and ROI?
Yeah, that is what. So as you saw in my presentation, we received 3 repeat orders after in both the cases where there were different MSMEs. So what we need to do is we will have to look at the final value proposition and the return on investment as was told by Dr. Devarajan. So if you do a value proposition by bringing in pre-processing and post-processing, it would be definitely be possible. But without that, it appears to be challenging, but it is not.
if you look at only the investment,
Yeah.
there's always a challenge. People say, no, it's very heavy, it's expensive,
Correct.
I can't bear the investment. But
Yeah.
if you work at the overall in terms of quality improvement, radiation reduction, people productivity improvement, the entire 7M conditions, I think it is a management's job,
Correct.
our job to make it successful, not only on the labor productivity.
Correct.
If you consider anything on labor productivity, definitely we are not ready.
Yeah.
We are not ready.
Yeah.
If you consider as a benefit, as an overall sense, definitely it is a thing for future. And that's the way in which I feel if you don't do it, I don't think we will be anywhere saying that we are next to China. So it is a part of survival, I feel, as a management, as a part of our own development of MSMEs or our own factory, we have to take the lead to survive.
Yes, yes.
Sir, the next question is from Mr. Prakash S. Can you share some examples of automation for non-mass production? In our case, we do multiple type of parts under 200 mm cubicles.
200 mm cubicle. Of course, I didn't understand that question, but the current use case, what I showed was 32 variants, and the customer was unable to forecast the batch quantity. So with the SMED concept, we did 15 minutes changeover time, in the sense when you move from, by the time the fixture setup is done on the machine, the end of arm tool setup is changed. So out of 32, we grouped it into families, and the variants were brought down to 4. So with that, we were able to achieve. So if I look at the real requirement, we can come up with a proposition in saying how we can achieve that. We can look at it. We need to look at it.
So the next question is, what skills are required for manufacturing team to deal with increased automation levels?
So one requirement is that the process mapping is very important. So before you get into automation, do the process mapping as precisely as possible. Number one. Number two is a little bit of reskilling is required in terms of when you use a gantry or a robo or a sensor or some kind of a requirement for meeting the automation. Try to get into that and learn the basics, and try to not treat that as a black box. These two things, process mapping is very important, and see how to simplify it, and then having little bit of reskilling, I think then the whole setup can be definitely met. And the classic case of the variant what I presented to you on machining, this customer is from a very remote corner of Maharashtra who is running this cell, and the owner himself is driving the whole process. The entire team is very excited, and they're able to meet the third automation cell in the shop floor, which means that already 15 machines with 3 robots are automated, up and running.
Can I add some point on the skill side?
Yes, sir.
No, the fundamental skill in automation is mechatronics. So the pneumatics, hydraulics is the first level. And then smart mechatronics has come up now. So the employees should understand how to make mechatronics smart also and how to use it. See, they're not going to design anything. They're going to use it only. Installation and commissioning and maintenance are the three things they must pick up in terms of skill level. The second level is a PLC and CNC. PLC and CNC are very familiar. And then a theoretical and practical training can be given. There are a lot of simulated equipments are available for PLC training and CNC training. The third level is the robotics and cobotics. So, and then finally the integration is graduate engineers and other people. I have seen in Titan Automation, they take only graduate engineers. Every year some 30-40 people, and they go through this entire gamut of training, what I'm talking here. And then at the end of it, they can understand the total automation. Diploma holders, you can bring them up to the subsystem level automation. ITIs, you can bring them up to the mechatronics level automation. So this is a kind of a, I mean, there are always exceptions to the rule. An ITI can grow up to the top level also, nothing wrong. So this is a normal pyramid of education versus skilling in the Indian industry. The other question Prakash asked about that variety of parts, multiple type of 200 mm cubicles is exactly the example. Probably he should visit his own company where I implemented a flexible manufacturing system with 32 fixtures and one palletizing system where all the 50 types of turning centers of Ace Designer are machined in one system with couple of horizontal machining centers and 32 pallet changes. So the batch process and the variety is best handled by what we all call as FMS systems.
Yeah.
And which is a high level of automation. And now digitalization is available. Intelligent FMS systems are now the order of the day.
Yeah. We did a small case study for aeronautical requirement where the raw material is a cube, the finished part is different. So this was handled by a robo on a track, and the material were different for different type of application. Maybe it's something like that. I need to look at it and then we can come up with an idea, not an issue.
And Mr. Venkata Kancharala, that question has been addressed by Rupa. Vision automation.
No, sir.
Vision automation and how to estimate the value addition of visual automation compared to normal.
Sir, what is the question?
Elaborate on vision-based automation. Could be Devarajan or you. Either of you can address this.
See, I find vision system in terms of assembly mismatches, assembly areas of different components. And today, vision systems are very low cost also. Okay, so we are able to compare and then use it. So based on the requirements of what we have, whether the component sorting, whether the level of the cost of vision system goes up based on the level of requirement. Suppose you want to measure the finish of paint, I mentioned in one of the presentation itself. That is a higher level of cost. Whereas low cost 1,000 rupees, 2,000 rupees vision systems are available today. We can interlink to our requirement in a system and make it happen. So that's the way I look at it. Jagannath, you can add, please.
Yeah. So there is something like part present or missing parts kind of a thing, which is almost very easy to do. But there are intricacies in terms of luminous intensity to which the camera is very sensitive. So one needs to take care of that. And also it cannot do precision parts all the time. Sometimes there is a issue with respect to even a small change in the luminous intensity. There are some issues. In fact, we did a extensive trial on identifying the oil hole contour on a crankshaft, and then do a chamfering which needs to be uniform on the periphery, because when there is an angular drill coming on the crankshaft, the oblong hole what comes is like an amoeba. It doesn't have a consistency based on the wear of the tool. We did this experiment, this work for almost 3 months, but we couldn't get that near perfect because of a lot of datum issues on a rotary axis. So there are many nuances in this. So if you really know the process very well, geometrically how you are going to hit, because when you're looking at a picture, going to that point is the most difficult thing. You can look at the picture, but how do you take the datum? That's the challenge. But if little bit of work is being done, with
Rupa, why the recording is stopped, Rupa? Why people are stopping the
It's really-
recording? Is it because your staff is going home? They stop the recording?
No, sir, we are all here only, sir.
No, recording is stopped. 2 times it stopped. Just check it out. Because the Q&A is the most interesting thing in record. Anyway, another point, Jagannath, I want to add here for the vision-based thing, where the non-engineering industry, like the FMCG industry, vision-based automation is become extremely important to check whether there is a wrong labeling of the wrong product and the wrong packaging. Number 1 example. Number 2 example, in pharma industry, the defects, like there was one example case study where iron filings from the equipment have gone into the tablet itself. Instead of buying iron tablet, they bought tablet with iron. It's a famous case study. Millions of tablets are to be taken back from the market. In pharma, you expect 0 defect. The third example is the shoe industry and garment industry. My good friend in Laguna Clothing is using a lot of vision-based automation. So the textile garment is stitching. You cannot measure anything there. It's not engineering industry where you put a vernier caliper or a CMM machine. No metrology involved. And so vision is used in these kind of products where I call it as attribute versus variable measurement. In the metrology jargon, attributes or the sensory organs, what you can see by hand, 5 senses, versus measurement, which is quantifiable metrology. So when you distinguish these two, vision-based thing is extremely useful that is on the quality measurement. In the process, I have seen both in TVS Motor, I saw a brilliant vision-based system, particularly when you have a model mix, multi-model system. I went to a Chennai company, always quote in my webinars, that there is a company making 200 clutches and brakes in a Chennai Korean company, Indo-Korean joint venture. I asked the quality manager, which is the biggest challenge. He said, mixing and mess up. Opening statement, mixing and mess up. What is this mixing and mess up? Sir, 200 clutches and brakes we are making. All of them look similar, sir. They go to tractor companies all over Punjab and whatever it is. Every tractor company make different clutches and brakes. It goes to spare parts market as well as OEM market. But no one has got the same spring, child parts, right? Or the tube which holds a spring, or the brake disc in the case of a brake, or the clutch plate, whatever it is. So the parent assembly looks similar, but child parts are different. Mixing and mess up. You cannot do anything in this unless you use vision-based technology. The value addition, my dear friends, is in terms of cost of quality. I think the point made by our speakers in the morning, the cost of quality, Mr. Periaswami, if it is measured by small company, big company, any company, is a one single ticket item which can justify all investments in automation and intelligent automation. Definitely it will justify, because we are not measuring cost of quality and we are just assuming, "Arey scrap to chodo yaar, baad mein dekhenge." No, start monetizing the cost of quality. And number 2, when the quality improves, you are getting more business. The business share of one company is more than the other company because your quality is better. The OEM is looking at the business share based on the parameters of the vendor rating. So both in terms of cost of quality reduction and business improvement due to satisfied customer, the vision-based automation is making a floodgate of improvements. And there is one company called Drishti Technologies who have done a phenomenal work in Toyota and other companies, but very expensive. It takes time to adopt all these things. But in a small way, as Mr. Devarajan said, low-cost vision-based automation should be started in both manual area, like the shoes and garments I mentioned, or the FMCG highly automated conveyor lines, and even for that matter, the engineering industry. I think now it is 6:04. Now I'll take 1 more minute to ask Jagannath a very, very difficult question. And then I request Dr. Devarajan to pass the vote of thanks. Jagannath, are you able to see?
Yes, sir.
How does M2 Next BFW transform existing equipment in the shop floor of customers to smart enabled in a multi-brand shop floor?
Yeah. So we are already executing this kind of a requirement. So to make it very short, we have kept the variations what could come on a machine. Like for example, today We are launching a product which can work on Fanuc controller, Siemens controller, Mitsubishi controller, without having any hardware in between, how to crack the library, how to work on the library. So similarly on PLC equipments, so on and so forth, we have worked out on the bus protocols. We have worked on the sensors, how these intelligent sensors are available with an interface, and how to bring them to a common level where when you're converting an equipment for digitalization into a smart equipment, you need to get the data seamlessly. So it's a big subject, but then we have worked
Of
out
course.
a methodology
Yeah.
to see how to make it affordable, how to make it seamless, and how to work on that. So today we are successful with 3 major brands where we can really take the data seamlessly, and it is possible. And the sensor evolution has been really great. So the sensor versatility today is you ask any kind of interface, DeviceNet, Profinet, IO-Link, you get all sorts of this thing. You can retrofit and continue to connect them to the intelligence and start doing the analysis.
All right. All right. How to maximize return on investment of the investment in digital manufacturing? That's the last question from my side.
Sir, as shown in my case study, like when we really worked on the process of pouring, for example, I take this die casting, we could eliminate 95% rejection because of porosity, 95% rejection. So we have to really little bit work on the domain to understand how the quality is captured. If required, put some sensors and start measuring that along with the automation. The ROI really becomes very fast, and the deliverables are committed. And as you said just now, the volumes on export, the volumes with respect to competition, your share starts increasing automatically, and the premium is also being paid because you are committing to the performance.
Great. I think these questions themselves require one webinar. I think in a 3-hour session, some of the people are still there listening to us, and it is a very long session. Originally, we planned it to do in a hotel, but the moment we came to know something outbreak in China, BCIC was very fast to respond and change it from a hotel to an online. That's an excellent job by Rupa and team. And we thank BCIC, and I request Dr. Devarajan, Senior Vice President BCIC, to pass the vote of thanks today. Thank you, Dr. Devarajan. I hand over the mic to you.
Thank you very much. I think it was an excellent. We thought it should be one day meeting outside, not in the online, and not the reason of COVID. Various other reasons we changed it. But however, we'll come back to the day's program, and it started very well. I think I should thank Rabindra Sahab interacting with Prakash and RGP in terms of bringing the PLM concepts in a very clear area. And we also talked about how affordable automations and bigger automation, like what Jagannath did mention. It was learning for all of us, and still we have a lot of.
And Prakash Quality 4.0 was eye-opener.
Quality 4.0, yeah, it was a very excellent meeting altogether. I think we will join again one of these days in face-to-face, probably after the COVID.
But very practical examples by Periaswami sir, and very practical examples by Jagannath made this particular program very, very successful. Imagine
Thank you very much.
Power of online program is proved even when Devarajan sir is already in the car. You can see that it's the most productive way working out of home. I think the COVID should not come, but whenever it comes, BCIC reverts back to the online programs. Thank you, Rupa. On that note, thank you, Dr. Devarajan. Thank you, Mr. Periaswami. Thank you, Mr. Jagannath. Thank you, Mr. Prakash G. And thank you, last but not the least, Mr. Rabindra Saha, who was the original author of this program. We just expanded it and made it into a very rich program. The 2 pillars of Industry 4.0 are definitely required, both OEMs and Tier 1, Tier 2, Tier 3 companies and MSMEs. On that note, we will part and wish all of you a Merry Christmas and Happy New Year. And
same to you.
Salam to Bangalore Chamber of Industry and Commerce. Thank you, sir.
On behalf
thank
of
you everyone.
Happy New Year and thank you very much. Thank you.
Very safe New Year, because COVID Omicron or some Micron is coming. It's probably Micron is not a 1,000th of a millimeter. In this case, it is a deadly virus which is coming back. And even if there are no direct flights from China, it has been found the flights coming in from Singapore and Thailand and other places are always carrying a couple of Chinese, and therefore it is spreading to India also. First 100 cases have been found. First 10 cases have been found in somewhere in Delhi. So be careful, and all of you have a safe New Year. Whenever you go in a crowd, you must wear the mask and also keep your own sanitizer in your pockets. Thank you very much.
Thank you.
Thank you, everyone.
Thank
Happy
you.
New Year.
Thank you.
Good night.
Stay safe. Thank you.
And
Thank you. Good night.
goodbye.
Thank you, Rupa. Thank you.
Thank you, Rupa.
Bye.
Brilliant work.
Thank you.
Thank you. Brilliant work, Jagannath.
Thank you, sir. Thank you.
Thank you, Devarajan, sir.
Thank you.
Thanks to all the participants. Mr. Shivanand is still there. Thank you, sir.